Yellarigu Namaskara. This is your Captain Shreyas, your physics master teacher. We'll be going live soon, so quickly mark your attendance by smashing the like button. Let's start with the derivatives first. I'll also show you the formulas and we'll see some problems. Then we'll go to integration, the formulas and the application. Okay. So to understand derivatives, let's talk about first concept, which is slope. And when I say the word slope, imagine there is a Pandu over here. Imagine there is a Pandu over here and he is going up the inclined plane. It is very, very steep. If that same Pandu had to climb this particular inclined plane, a staircase or maybe a ramp or just a ground which is at an angle, he will be even more sad. He will be even more sad because he has to go on a steeper plane. Probably a Pandu who is going on a flat ground, he will be probably okay, neither happy nor sad. Fine, his mood is okay. But if the same Pandu had to go like this, I think he will be little bit happy because he does not have to use much of energy. Gravity will do its job. And if the incline is even more down, then he will be even more happy because the gravity will help him even more. So this is the concept of slope and steepness. Yes, Pandu and Champa is back. Yep, Pandu and Champa is back. So this is the concept of slope and steepness. So slope of anything is basically the steepness. How steep it is. How steep it is. The steepness of that particular line, the curve, the plane, the ground, the surface below, or a graph, whatever. Okay, so that is the steepness. So this is decently steep. This is more steep. This is not at all steep. So here I would say that the slope is zero. Here the slope is basically a big fat zero. Do you guys agree with it? This is neither going up nor going down, so it is zero. Whereas over here, I would say that the slope, because you're going up, is positive. Whereas over here, I would say the slope is even more positive because I'm going even more up. The rate is more. Here, I would say because I'm going down, the slope is basically negative, okay, with a minus sign. And in this case, the slope is even more negative. So the more down you go, more negative it becomes. The more up you go, the more positive it becomes. If you are neither going up or down, it becomes zero. Is this positiveness, negativeness, and zero concept of the slope absolutely clear? Give me thumbs up. Yes, everyone with me on this? Is this concept absolutely clear? Positive, negative, zero. Okay, taken the example of Pandu for this. So now imagine this. Let's create duplicates. Yeah. Now just imagine this. Everybody has seen graphs at some point of time or will see graphs at some point of time. So, in physics, chemistry, probably even biology, graphs are an important part. They are an integral part of your studies, obviously. So let's say for example, my dear students, this is x-axis, this is our origin, and this is our y-axis. Okay, so this is what it is. And I have a graph drawn of something. Maybe it could be anything of some curve, some line, etc. So for now, let's take just a line. For now, let's just take a line, or let's say we just take a random curve. Doesn't matter. Okay, it could be any curve. It could be any curve. It could be any line. Doesn't really matter, my dear warriors. I take any two random points on the curve, and I want to know between those points how quickly am I going up or down, what is the rate of change, what is the steepness of that graph in that period, in that region. Let's say for example that region happens to be from here to here, from here to here. So what I will do, the first thing is, let me just go down below over here. Let me just go down below over here and go down below over here. And this I will call it as x1. This I will call it as x2. What is x1 and x2? x1 and x2 are the coordinates, x coordinates of the 2 points between which I want to find How quickly am I going up or going down, the slope, the steepness of this particular graph, whatever this curve is. They are the x coordinates of it. Everybody agrees to it. So now, between these 2 points, if I measure this distance, x2 minus x1, this whole thing is x2, this thing is x1, this is x2, this is x1. So this will be nothing but x2 minus x1, which is also called as delta x, which is also called as delta x. Delta stands for change. Once when Pandu met Champa after a long time. Pandu told Champa, Champa, there is a lot of delta in you. Champa was confused. Then Champa attended Shreyas sir's class and then she understood, oh, delta means change. So she asked Pandu, do you mean I have changed? Pandu said yes. So delta means change. So next time you want to put this sentimental dialogue on someone, you can say, there is a lot of delta in you. Okay, so delta means change. So from x1 I have gone to x2, there is a change. This much is the change of the x coordinate. In this region, as x coordinate changes, even the y coordinate changes. Even the y coordinate is changing, my dear warriors, right? So let's see how much is that y coordinate change. Let's see how much is that y coordinate change. Let me just drop a horizontal line like this as well as like this, and let's see. This point will be y1, this point will be y2. So the y coordinate has changed this much. So I will just show it over here like this. This much is y1, this much is y2. y2, y1, this will be y2 minus y1, the leftover. So this will be nothing but y2 minus y1, which will be delta y. The change in y, delta y. Change in x, delta x. So when x changed by so much, y changed by this much. So the manner in which I define the slope in this case will be as follows. Understand, the slope between this and this point has continuously changed by drastic amount, and what I will find will not be the slope at that moment, at that instant, or the rate of change at that particular point. Rather, it would be over a duration, over a range of values. So, whatever I will find, the slope, the steepness will no longer be instantaneous. Rather, it should be average. On an average from here to here, what is the average rate at which I have gone up or gone down? I hope you guys see that. It's not instantaneous, it has to be average. So therefore, I will say average slope will be nothing but how much my y changed. So change in y coordinate upon always the vertical axis, or you can say vertical change in vertical upon the change in horizontal direction. The usual symbol of slope is m. Because I am finding average, I will put avg, which is the average slope. The symbol of slope is m. Change in the vertical direction is delta y. Change in the horizontal direction is delta x. Hence, this is the formula of your average slope. M average is nothing but delta y by delta x. Is that absolutely clear, my dear students? Yep, my warriors. Is it clear? M average, the average slope, is how much the y changed upon how much the x changed. Just to give you a simple, easy peasy example over here, imagine, just imagine, just like I have drawn the graph over here, I'll draw a simple graph. Let's say the graph was like this, and I want to find between this point and this point, how much is the average slope. So this is obviously having 0 coordinate. Let's say this coordinate is 3 units, and over here, sorry, this is 0, maybe this is 1, this is 0, this is maybe 9 or something. Okay, and at this point y coordinate is 0, you can see. And if I go over here and I mark this point, let's say it comes out to be something like 4 or something. Just chumma, I'm giving some random graph over here. If I ask you what is the average slope between x is equal to 1 and 9, What is your answer? Let's try to find out. The average slope formula is the delta y by delta x. What is delta y and what is delta x? From here, this point to this point, can you see this much is basically delta y? This much is basically delta y. I think it is 4 minus 0, which is 4. Between this point and this point, do you see how much is delta x? It is 9 minus 1, which is basically 8. So hence, delta y is 4, delta x is 8. Hence, the answer is 0.5. Hence, the answer is basically 0.5. Is that clear, my dear warriors? Yes? Yep. I hope you see it is not 9 minus 0 between 1 and 9. So 9 minus 1 is 8. A lot of you said 4 by 9. No, that is not the answer. It is 4 by 8. Yes, which is 0.5. Excellent. Similarly, imagine if I give you another example like this, and let's say the graph goes like this, and I take some two random points, maybe one over here and maybe 1 over here. Let's say this is minus 2. Let's say this is plus 5. And let's say these 2 points are at the same level and this is, let's say, at 3. And if I ask you right now, what is the average slope between minus 2 and 5? Between minus 2 and 5, x coordinates minus 2 and 5, what will you do? Again, use the formula. M average is a delta y by delta x. Delta y is nothing but y2 minus y1. Delta x is nothing but x2 minus x1. How much did I go up by? Just check. Here I was at 3. Here also I am at 3. So I did not really go up at all. Yes, my delta x is there, which is 5 minus 2. But doesn't matter what is there in the denominator. Numerator is 0. So the answer is 0. From this point to this point, I have not gone up nor gone down. On an average, I have maintained my level. So the slope is 0. Everyone with me? Is this clear? A lot of people make a mistake. They say the answer is 3 by 7. That is wrong. Understand, y2 and y1 both are same. Here y2 is basically 3. Here y1 is also basically 3. So 3 minus 3 is a big fat 0. 3 minus 3 is a big fat 0. Understand that. So it is 3 minus basically 3 again. So which is a big fat 0. Clear? Understood the concept of average slope? Pakka, so many mistakes you could have made had you not attended this class. Sir, this would be my second attempt. Very good, Mitali. So don't worry, there are a lot of students just like you, and I'm proud of you that you have taken this decision of taking a drop because you want to become a doctor, and we will support you. Make sure you are attending all the classes over here and following the instructions. I'll be making now proper NEET 2025 and NEET 2026 content. Stay tuned on the channel by subscribing and liking. Okay, great, Mitali. I'm proud of you to make this decision. Moving on. Okay, yes, Saran, I'll be doing that. Moving on now. Now that you have understood what is average slope, let's understand this concept of instantaneous slope. So, my dear students, my dear warriors, imagine some random curve. Imagine some random curve. I don't want a range between which I find the average slope. I want to find at a moment. They say, right? Live in the moment. Live in the moment. Meaning at this instant, neither front nor back, at that moment. Meaning the time interval is extremely small, but it is not zero. What do I mean by a moment? Can you tell me how much does a moment's value measure? What is the meaning of a moment? If I tell you, at this moment, if I ask you how much time it is, what is the time of that moment? How many seconds does it mean? Put it up in the chat box. Put it up in the chat box. Hi, Hitman. Yes, very good, Asim. Awesome. Very good, Krishna. Satyashri is also second attempt. Yes, what do you mean by the moment? Is it 1 second? No. You can have a time which is less than 1 second also. Is it 0.1 second? Well, it is small, but it is not a moment. Moment is even smaller than that. 0.001, even less. 0.00001, even less than that. I'm not talking moment of time. I mean, at this moment, living in the moment. 0.000001. Asim is saying 0.00000000000000000001. This is not a moment because I can always add one more zero in between and I can make it smaller, no matter how many zeros you add. So the moment which is extremely small, extremely, extremely, extremely small value of, let's say, a change of a change is represented as, or it's called as, infinitely, infinitely small value, infinitely small value, and it is then called, it is then called, it is then called, let's say delta x tends to 0, which is the same as writing just dx, which is the same as just writing dx. Delta x tending to 0, where instead of writing all these things or in the word form, you just write dx. When I say delta x tends to 0, it also means delta x not equal to 0. Delta x not equal to 0. It is very, 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 very small, but it is not yet 0. I mean, it's too small, tending to 0. Understand that. Okay, you cannot write the value of this. So a lot of people think dx has a value. No, guys, understand, delta x I can write 0.1, delta x I can write 0.6, delta x I can write it as 0.00000002, delta x I can write it as 2.4 also, delta x I can write it as 1 by 1000 also. These values are permitted. Okay, but understand I can never ever write dx as 0.00001. No, this is wrong. This is wrong. I do not know the value. The value is unknown. The value is basically unknown. The value is basically unknown. But it is small. It is small and not 0. It is small and not 0. That is what dx means. That is the difference between delta x and dx. A lot of you probably did not know this, so I'm making it very, very clear. So when the value becomes extremely small, I say delta x tends to 0. I represent it as dx, but dx does not have a value, unlike delta x, which can be written down as a number. Okay, so this is an infinitely small value. This is an infinitely small value, whereas over here I can say this is finitely small. Finitely small. Finite means which you can measure. Infinitely means which you cannot measure. You can measure these values: 0.1, 0.6, 0.0002, 7, 0.4, 2.4, 1 by 1000. These are finitely small, meaning you can measure it. These things you cannot measure it. Clear? Okay. So coming back to this, at the moment, what I will do here, I'll just take two neighboring values which are separated by a very, very, very small distance. On the board, I cannot show the dx. This is highly exaggerated form. This is highly exaggerated form. Please understand it. And these are basically shown like this over here. So this particular distance between these two dotted lines is basically dx. This distance between these two particular dotted lines over here, my dear warriors, that is basically your dy. That is basically your dy. If you zoom onto it a little bit, if you zoom onto it like heavily, you will see that that particular curve is actually a straight line because you have taken a small part of the curve. Think about it. Any curve, if you say, any curve, if you see, you will see that it is made up of small straight lines. You might have played with the railway tracks, or you might have played with some pins or some sticks or some matchbox, those matchsticks and all that. You arrange those matchsticks in a funny manner or in a curvy manner. You can see from the distance it looks like a curve, but if you see in reality, it's made up of small straight lines. So if you zoom onto it over here, my dear students, you will see a nice little straight line over here. nice little straight line over here, and these two dotted lines are like this, and these two dotted lines horizontally are basically like this. So hence, this distance, how much will it be? This distance, how much will it be? It will be dx. And this distance, my dear warriors, this distance, how much will it be? It will be nothing but dy. And you are getting a nice little right angled triangle. You are getting a nice little right angled triangle. In fact, I will also mark this particular angle as theta. I'll mark this particular angle as theta. Okay. So you will be seeing that there is a use of this theta in the later on. Till this part, everybody is clear? Till this part, everybody is clear? Okay. Now, what I will do is, because it's a straight line, if I extend it on both sides, if I extend it on both sides like this and like this particular line will then become the tangent. This will then become the tangent. Your curve might go anywhere. Your curve might go anywhere. It could be like this. Your curve could go anywhere. But if you extend that line at that instant, that's it. It is going to become the tangent. So I can just draw a beautiful tangent right over here. Maybe something like this. Okay. So this is our tangent, which I have drawn. Okay. This is the tangent. This is the tangent to the curve, to the curve. Whatever angle the tangent makes with the x-axis, if I mark it as theta, don't you think, don't you see that the same angle theta will be also over here? Because if you draw a horizontal line, even this will be theta. Two parallel lines, these two angles are always congruent. So do you see that if this is theta, even this is also theta, or if this is theta, this is also theta. Till this point, everybody agrees? Give me a thumbs up. Till this point, everybody agrees? Everyone? Everyone? Okay. Okay. Very good. Very good. Very good. Awesome. 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 Clear? Okay. Very good. Okay. Now, if I ask you, what is the instantaneous slope? Remember, for average slope, the symbol that I used was m average. For instantaneous, I don't have to use any symbol. I just leave it as m. So this then becomes the instantaneous slope. So instantaneous slope, instantaneous slope will be small change, small delta in vertical upon a very, very small change in the horizontal. So that is represented by m. That small change in the vertical in this case is nothing but dy, and the small change in the horizontal is nothing but dx. But the best part, if you look at this triangle, dy is opposite, dx is adjacent for theta. So hence, is it not tan of theta? Is it not basically tan of theta, my dear students? That's it. So instantaneous slope is represented as dy by dx, not delta y by delta x. That is also tan of the theta. Theta is angle made by the tangent with the horizontal line. Theta is the angle made by the tangent with the horizontal line. You might be wondering, sir, can I cancel this d and d? Very good. Nice thought. Then tell me, why did you not cancel delta over here? If that is the case, why did you not cancel delta? Reason is delta is not a variable. Delta is a function. It's an operator. It's an operator. Then you will do all random things in life. Like for example, somebody will say, sir, sine of x by tan of x. Sir, n and n will cancel. X and x will cancel. Sir, it is psi by ta. Psi by ta. You can do all these things. Understand, sine is not s into I into n. It is a operator. Okay, it's a function. So same way, delta d is an operator. You cannot do those kind of random things over here. Correct? Very good. Now, another interesting thing. This dy by dx, this dy by dx is called as the derivative of y with respect to x, one way of writing, or you can also call it as differentiation of y with respect to x. Then you can also call it as of change, rate of change of y with respect to x, or you can just call it dy by dx. All these things mean the same thing. All these things mean the same thing. You can also call it, I don't have space, so maybe I'll just write it over here. This was dx. You can also call it the slope, the slope of the tangent to the curve, of the tangent to the y-x curve, y versus x graph. Okay, all these things mean exactly the same thing. Now let's take numerical problems to understand this. Let's take numerical problems to understand this. First of all, tell me, do I know the value of dy or dx? Can I measure that value? No, right? I hope you remember. I told you some time back, they are infinitely small, they are unknown. You cannot tell me the values, they are immeasurable. So, a lot of you might have also thought, how the hell are we going to measure this ratio? Because dy value, if you ask me, I don't know. Dx value, if you ask me, I don't know that. But then, how do you measure dy by dx? Numerator, don't know. Denominator, don't know. Numerator by denominator, I know it. How? Tan theta. If I draw a tangent, measure the angle, I can get the value. That is the funny part about derivatives. That is the interesting part about derivatives, that in spite of not knowing numerator or denominator, I know the value of numerator by denominator by finding the tan theta value. So let's take examples so that you understand this. Say for example, I take a random graph like this and show it like this. And let's say, maybe at this is x is equal to 2. I want to find what is the slope. I want to find what is the rate of change. I want to find the derivative. So at that particular point, I'll just go up, and at that point, I'll just draw a tangent. I will measure this angle. Let's say I found out the angle comes out to be 60 degree. So my dear warriors, if I ask you, what is the slope? What is the slope at x is equal to 2, which is basically dy by dx. I don't know dy or dx, but I know the tan of the angle made by the tangent. So tan of 60 degree, tan 60 is nothing but root 3. So hence the slope will be approximately 1.73. So that is the slope at x is equal to 2. We got this answer. We got this answer by drawing the tangent. Interesting, isn't it? Similarly, let's say somebody asks you, what is the slope at x is equal to 0? You'll be like, okay, it is again dy by dx, but you have to go at x is equal to 0. X equals to 0 is over here. This is the origin. Go down here at this point. If you draw a tangent, it is like this. What is the angle made by the tangent with the horizontal? 0. So it is actually tan of 0. Hence the slope is 0. So the slope at x equals to 0 is 0. The slope at x equals to 0 is 0. Is this absolutely clear, my dear students? Yep, very good. Similarly, somebody tells you, hey, listen, I want to find the slope at maybe, I don't know, at x is equal to minus 1, as x is equal to minus 1. So you go down here, and at this point, let's say you draw a tangent. And it so happens this makes an angle of 45 degrees. 45 degrees with the horizontal. Example, okay? So now you have been asked, what is the slope at x is equal to minus 1, which I know is tan of this angle, but be careful, it is not up, it is down. So even if you write tan of 45 degree, I have to put a minus sign. Why this minus sign? It is down. Actually speaking, it is tan of minus 45 degrees because Understand this concept. If I'm taking this as the horizontal, all the angles which I go here will be positive, whereas all the angles which I go down over here will be negative. If I'm going down, this will be negative. If I'm going up, that will be positive. So actually it is minus 45. But do you remember that rule? Tan of minus theta is minus tan theta. It is actually minus of tan theta. So it is basically tan of 45 with a negative sign, which is minus 1. Hence the slope at x is equal to minus 1 came out as minus 1. It came out as negative 1. That's how it is. Okay. Is that clear? Okay. Everyone with me? Everyone with me? Okay. Okay. Great. Come on, come on, come on, come on. Come on, come on. Yes. Let's go ahead. Shivani, Mitali, concentrate on the class. Concentrate on the class. Yeah, don't waste your time doing random time pass. Come on, focus on the class. Okay. Now that you have understood it till this point, you might be wondering, sir, every time the question won't be graphical, no, sir. Every time the question won't be graphical, no, sir. Like, fine, this is graphical, then we can draw the tangent, we can get the slope. Sir, what if the question is not graphical? So then we go to the analytical method. Then we go to the analytical method, and let's see what is the analytical method. In fact, it is very, very simple and straightforward. Imagine, imagine you are not given the graph. You don't know the graph. When graph is unknown or not feasible or not feasible, or equation is given, equation is given, equation is given. Say for example, y is equal to x cube. I know y is equal to x cube. The graph, if I draw it, fine, it will look like this, but drawing it will take time, and plus it should be accurate. Or if I do not draw it properly, all right, if I make some mistake in that, then when I draw the tangents, it might have some error in it. The angle will be a problem. And what if the angle is not a standard angle, like tan of 50 degrees, tan of 47 degrees? You cannot do all those things. So that is the reason why we need to go with next method, which is the analytical method. Then what you do is we go with the analytical method. Analytical method. Analytical method. When equation is given, graph is not given, graph is unknown, not feasible to draw it, or there might be some error, all these problems. So then we go to the analytical method. So in analytical method, what happens is you are given a function. You are given, you are given a function. You are given a function. What is function? Function means you give me x, I will tell you y. You give me something, I will give you the output. You give me the input, I will give you the output. So a function is like a magical box. A function is like a magical box where you give in some input, for example, let's say x, and you get an output. You get an output, which is, let's say, y. It is represented like this. Y is some function of x. Y is some function of x. For example, I tell you that if I give the input as 1, I get output as 1. If I give the input as 3, I get the output as 9. If I give the input as 0, I get the output as 0. If I give the input as 2, I get the output as 4. If I give the input as 5, I get the output as 25. Can you guess what this function is? Can you guess what this function is, my dear students? Yep. Can you guess what this function is? What is this? Yep, it is a square function. So my y is just x square. Y is just x square. So squaring is that function, because whatever number you give, it is squaring it and giving. So that is that magical box. That is that magical box which is just squaring it and giving it. Exactly. So that is the meaning of any function. If I know the function, then My God, what just happened? If I know a function, then 100% that function will also have some graph, which I do not know, how it will be, but some graph will be there. Some graph will be there. Okay, I'm just showing some random thing. If I want to find the derivative, that means I basically draw a tangent, and this is theta, this is the tangent to the curve, and all of that. If I want to find the derivative, that means dy by dx. It is also represented as f dash of x. When I put f dash, that means I have taken the derivative. I have found the slope. I am finding the rate of change. I am finding the differentiation of that particular graph, that curve. I'm drawing a tangent and measuring the tan theta. That is basically tan of theta, but I cannot measure theta. So there is a process. There is a process, or there will be a process, or basically there is a formula which will give me the answer. If this works, good. If this doesn't work, then use the formula. So we are going to see what those formulas are. We are going to see what those formulas are. Is this clear, my dear students? Is this absolutely clear? We are trying to find the derivative, which is also represented as, shown as symbolically, f dash x, which is also tan theta. Some books also use this symbol. They will call it as y dash. Y dash, dy by dx, f dash x, all of them mean the same thing. Don't get scared. They are all exactly the same thing. Cool? Yes, very good. So, what is that formula? You will be surprised to see how simple our job becomes. How simple our job becomes when you use that formula. The formulas are as follows. If the functions, I'll show the functions over here, and then I will show what is the derivative over here, which is f dash of x. Very, very important. So if the function is basically, x raised to n, then the derivative of that function, the dy by dx of that function, is nothing but nx raised to n minus 1. Basically, what I'm trying to say over here is, if you differentiate this, okay, what you get is n into x raised to n minus 1. Derivation you don't have, don't bother, don't care. Only in JEE maths it comes, in JEE physics also it does not come. So don't worry about it. Similarly, if you have a constant function, then the derivative, then d by dx of that constant comes out as 0, because it's a constant, it is not changing at all. So it should be 0. Think about it, it's very logical. Similarly, if my function, is e raised to x, e is that, that natural number 2.7, right? So then the derivative of e raised to x, comes out actually as e raised to x only. This is the interesting part. E raised to x does not change, it comes out as it is. Similarly, if I have log of x, ln x, then the derivative of d by dx of ln x comes out as 1 by x. Continuing this process further, I'm just giving you some basic formulas. We are going to see the application of it. Don't worry. Just for now, look at the formulas. If it is basically sine of x, then we can also go to cos of x and all of that. Just showing you some basic formulas. Sine of x's derivative, d by dx of sine of x, is basically cos of x. Derivative d by dx of cos of x is negative sine of x. So these are some standard, most commonly used derivatives, my dear warriors. Most commonly used derivatives. This is the starting part. Let's understand it. In fact, there are many formulas. I think I have put it somewhere over here. Okay, where is it? See, derivative of x raised to n, derivative of sine x, derivative of cos is minus sine, derivative of tan is sec square, derivative of cot is minus cosec square, derivative of sec x tan x, Okay, derivative of cosec x is cosec x cot x, derivative of e raised to x is e raised to x, derivative of a raised to x is a raised to x log a, derivative of log of x is 1 by x. These are the formulas which you need to know for NEET physics. That's it. Don't worry about this right now. For this, this is the most important formula list. Okay. Now let's understand what do I exactly mean by this. Imagine. Let's take an example, my dear warriors. Only through examples you are going to understand it. For a moment, take a screenshot, write it down on a piece of paper. Write it down 2 times. I'll give you 1 minute. Write it down. All these basic formulas, write it down 1 or 2 times. Let it enter your head. Let it enter your head. Even if you're watching this recorded, just write it down. Within 1 minute, these formulas again and again. Only the orange part. Even if you don't write the yellow part, it is okay. At least the orange part. Derivative of x raised to n, nx raised to n minus 1. Derivative of constant, 0. Derivative of e raised to x, e raised to x. Derivative of ln x, 1 by x. Derivative of sin x is derivative of cos x. Derivative of cos x minus sin x. Just write down this at least 1 to 2 times. Done, written. Okay, perfecto. Now that it is there in front of you, because I won't be going back to this slide. All right, so let's see what the problems will look like. Example, let's say I want to find derivative of x cube. First of all, understand this is of the form x raised to n. So here this number 3 is like that n. So what happens is that n comes outside. So what happens is that n comes outside, which is basically 3. And what remains inside is n minus 1. You see, n minus 1 power remains inside. So this will become 3 minus 1. So hence this will become 3x square. That is the answer. Now you'll be like, okay, sir, what is so magical about this? See, I don't know how the graph looks like, but if the question asked you, what is the slope? What is the slope? What is the slope at x is equal to 2? Then all you are going to do is, I found out the value of the slope over here. If you notice, this is the slope, which is 3x square. So the slope at x is equal to 2 will be, substitute x as 2. So 3 into 2 square. 2 square is 4. 4 3 is 12. That is the answer. 12 is the answer. You don't have to draw a graph. You don't have to find the tan. You don't have to find the cos. Nothing. Directly you got the answer by using the formula. That is what I was mentioning over here in the analytical method. No need of graph or anything. Only if you know the formula, you will directly get the derivative, which is the slope of that particular graph. So that's it. Let's take more examples so that you are very super duper confident about this. Super duper confident about this. Okay. Next example, my dear warriors. Find the slope of y is equal to sine x at x is equal to pi by 3. That is the question. X is equal to pi by 3. First of all, this is the function. If I want to find the slope, which is m, I have to find dy by dx. Here, y is nothing but sine of x. Y is nothing but sine of x. What is the derivative of sine x? I just showed it to you. Sine x's derivative is cos x. Sine x's derivative is cos x. So the answer is basically cos x, but you cannot leave the answer like that. I have to substitute x is equal to pi by 3. Substitute x is equal to pi by 3. What is pi by 3? Pi by 3 is basically 60 degrees. Cos of 60. What is cos of 60? It is basically half. Hence, the answer is half. Hence, the answer is half. As simple as that. Right? Let's go to the next question, my dear warriors. On your screen now. Find the slope at x is equal to 5 for y is equal to ln x. Y is equal to ln x. That is the question. Y is equal to ln x. First of all, if I want to find the slope, means I have to find dy by dx. That means I have to find the derivative of ln x. Instead of y, I have put ln x. What is the derivative of ln x? I just showed it to you right over here. It is nothing but 1 by x. It is nothing but 1 by x. So just put 1 by x. But I have to put the value of x as 5 in the end. So 1 by 5 is the answer. That's it. The value of the slope is 1 by 5. Isn't this method much simpler? Without drawing tangents, without drawing or measuring angles and finding the tans? Yep. Very good, Krishna Meghna. Awesome, Satyashri Baswaraj. Very good, Savita. Very good, Meghna. Awesome, awesome, awesome. Kudos to all of you. Now, let's proceed ahead. Let's take more examples to find the derivative. Hold on. Let me just get rid of this. Okay, let's see if you guys can find the derivative of this quickly in the chat box. Derivative of x square is how much? Next question. Derivative d by dx of x raised to 70 is how much? Next question. Derivative of root of x is how much? Next question. Derivative of x is how much? Okay, chalo, figure this bit out for all these questions. Come on, my dear students, it's not that difficult. Try to solve these questions. 4 questions on your screen. First question, I'm pretty sure you would have figured out. 2 is basically that n over here. So the 2 will come outside, and what will be remaining is x raised to 2 minus 1. 2 minus 1 is 1. So it will be just 2x. So answer is 2x. Let's see how many of you wrote it. 2x. Very good, Meghna. Very good, Krishna. Awesome, Baswaraj. Very good, Satyashri, Sara. Excellent. What about this? 70 will come outside, and this will be x raised to 70 minus 1, which is 70 x raised to 69. Perfect. Many of you got the answer as well. Very good. Proud of all of you. What about this? Well, I can write this as the derivative. Root means x raised to half. So that half comes outside. X raised to half minus 1, which is half into x raised to minus half, which is 1 by 2 by x raised to half below, which is 1 by 2 root x. So answer is 1 by 2 root x. I've done it stepwise. Root x is x raised to half. That half comes outside, half minus 1 power will be reduced. So half minus 1 is negative half. Negative power means I can bring it down. X raised to half is root. So root x below with the 2. That's it. That is the answer. Very good. If you guys got it, proud of all of you. What about the last one? What about the last one? This is the same as saying derivative of x raised to 1. So that 1 will come outside into x raised to 1 minus 1, which is basically 1 into x raised to 0. X raised to 0 is also 1. So the answer is 1. Answer is 1. Yes. Got it? Everyone? Let's proceed to next few problems coming up on your screen. Find the derivative of d by dx of 1 by x. How much it is? Next question. Find the derivative of 1 by x raised to 3. How much it is? Next, find the derivative of x raised to 0.8. How much it is? These are the 3 questions. 3 next questions. Come on, figure this bit out. Everyone with me on this. Let's see the first one. X is below, don't do anything. Now take it on the top. Always write it in the power form. D by dx, always bring the powers on the top. It will become x raised to minus 1. Now write it properly. It will be minus 1 into x raised to minus 1 minus 1, which is minus 1 into x raised to minus 2. So I can just write it as negative 1 by x square. Negative 1 by x square. X square will come below. Very good. Excellent. Proud of all of you. How about this? Bring that cube on the top. So it will become derivative of x raised to minus 3. Okay, so this will just become minus 3 into minus 3 into x raised to minus 3 minus 1, which is minus 3 into x raised to minus 4, which is as good as saying minus 3 divided by x raised to 4. Minus 3 divided by x raised to 4. Is that clear? Yep, everyone? Got it? Kudos. How about this? Take that 0.8 outside. Take that 0.8 outside. It is into x raised to 0.8 minus 1. which is basically 0.8 into x raised to minus 0.2. If you want, you can write it as 0.8 divided by x raised to 0.2. X raised to 0.2. That also you can write it. Okay. This is how you solve these questions. Let's do one more question, one last question, maybe. Let's see if you guys can figure this out. Find the derivative of 1 by root x. Come on, let's see how many of you can do it the quickest. I want to see the answers being spammed in the chat box as soon as possible. Last question on your screen before we take up many other rules. Okay, before we take up other rules. Come on, my dear students. Yep. Come on, come on, come on, come on. Everybody. Very good. First thing what you will be doing is take that root x on the top. In fact, it will be d by dx. Root x means x raised to half. X raised to half, but it is below. When you go on the top, it will become negative power. So x raised to minus half. So minus half comes outside. X raised to minus half minus 1, which is minus half. X raised to minus 3 by 2. Negative power, I can bring it below. So minus 1 by 2 raised 2 into x raised to 3 by 2. That is the final answer. Minus 1 by 2 into x raised to 3 by 2. That is the correct answer. Yep. Be careful. Satyashri made a mistake, I guess. Check this out. If you guys got this answer, kudos if you got it right. Very nice. Very nice. Shall we move ahead to the next one? Shall we move ahead to the next one, guys? Okay. Now, the next set of rules which are going to come. The next set of rules which are going to come. All right. Now, there are many rules in derivatives which we are going to see. Okay. Once you learn these rules, it becomes very, very simple. It becomes very, very simple, easy peasy. So, what are the rules? Let's have a look. So, the rules in derivatives. The rules in derivatives. Okay, some of the formulas. The first formula which you should know is when I want to find the derivative of some function, and let's say it is k into x. Okay, k into x. Sorry, not that k here. That k is here. K into f of x. Then you can take that k outside and then find the derivative as it is. Then you can find the derivative as it is. Okay, so just 1 second. Let me. Okay, so this is the first rule of the derivative. Let me show it to you by an example. Imagine I want to find the derivative of 5x squared. This 5 is like that constant. You can bring it outside. So it will become 5 into just simply the derivative of x square. So which is basically 5 into x square's derivative. Take that 2 outside. X's power reduce it by 1. So it will become 2 5s are 10. X's power will just be 1. So the answer is 10x. Similarly, if I want to find the derivative of cos of x, sorry, 6 cos x, 6 cos x. What I can do is bring that 6 outside. So it will become just the derivative of cos x. 6 is outside. So derivative of cos is basically minus sine x. So the answer is minus 6 sine x. That is the answer. So this is that simple rule. If there is a constant being multiplied, take that constant outside, the derivative and do the derivative process normally. That is the first rule. The next rule that you have is this one. Imagine you have a functions being added or subtracted to other function, being added or subtracted to, let's say, some other function. Then when you want to find the derivative of that entire thing, you can find the derivative separately and then add or subtract it. So it will be just d by dx of f of x plus minus anything into d by dx of g of x. As simple as that. Let me show this to you by some examples. Say for example, you want to find the derivative of sine of x plus ln x. Okay, you want to find the derivative of sine of x plus ln x. You find the derivative of sine of x separately. You also find the derivative of log of x separately and add them. So sine x's derivative is just cos of x. Log x's derivative is just 1 by x. That is the answer. Another example which I can show you. Imagine you want to find the derivative of x square minus sine of x square minus sine of x. What you will do is just find the derivative of x square separately and also find the derivative of sine of x separately. Derivative of x square will be 2 into x raised to 2 minus 1 and sine x's derivative is just cos of x. So it will just become 2x minus cos of x. 2x minus cos of x. Is that clear, my dear students? Yep, very good. 2x minus cos of x. Perfecto, perfecto. So this is how you use the addition subtraction rule. The next rule that you have is the multiplication rule. The next rule that you have is basically the multiplication rule and then you have the division rule. So let's come to that. So multiplication rule, derivative of f into g, some function into some other function. What you will do is, you write down the first function as it is, multiplied by the derivative of the second function, plus write down the second function as it is and write down the derivative of the first function. So g dash means the derivative. If I do not put dash, it is as it is the function. So let me demonstrate this to you by an example over here. Imagine I want to find the derivative of sine of x into ln x. These are two functions. Sine is f, g is ln. So what I will do, I'll write down the first function, which is sine of x as it is. Derivative of the second function, d by dx of ln x plus second function, which is ln x as it is, derivative of the first function, derivative of basically sine of x. That's all. So, my dear students, what will happen is sine of x into what is the derivative of log x? It is just 1 by x. Then plus log of x into what is the derivative of sine of x? Well, that is cos of x. This is the answer. This is the complete answer. Cool. Let's take another example, my dear students. Imagine I want to find d by dx of e raised to x into x raised to 4. X raised to 4. These are two functions which are being multiplied. This is f, this is g. So write down the first function as it is, the derivative of the second function. Then the second function as it is, derivative of the first function. E raised to x is coming as it is. X raised to 4's derivative is nothing but 4x cube. 4's power will reduce by 1, will become 3. The next term will be x raised to 4. And what is this? Derivative of e raised to x is e raised to x only. So it will just be e raised to x. It is just be e raised to x. If you want, you can take out a few terms common like x cube into e raised to x is common, and here you will be left with 4 and here you will be left with x. So that is the final answer. Yep. Everyone clear about this? Clear about this concept? How to use product rule? Okay, we have seen, if there is a constant, bring that constant outside. Addition, subtraction, separately you do the addition, subtraction. Multiplication, first function, second derivative, second function, first derivative. First, second derivative, second, first derivative. As simple as that. Now comes the next rule, which is the quotient rule or the division rule, which is the division rule. So if I have d by dx of f by g, one function by another function, what you do is, first of all, you put the denominator square, okay, and then you write it down like this: g f dash minus f g dash. That is it. Second function, first function's derivative minus first function, second function's derivative divided by the square of the denominator. As simple as that. Okay, let's take an example to understand this. This is simple formula. So let's say we take, I want to find, let's say, derivative of tan of x. Now remember, tan of x's derivative, I can find it directly using the formula, but using the division rule also I can do this. I can write it as sine of x by cos of x. Here sine is f, g is cos. So first things first, in the denominator, put denominator square. So it will be cos square x. In the numerator, the denominator first. Always start with the denominator. Then the numerator. Numerator is sine. So derivative d by dx of sine of x minus numerator, which is sine of x, into denominator's derivative, which is cos x's derivative. Let's see what do we exactly get over here. Okay, so cos x into sin x's derivative is again cos of x only minus. This is sine of x and cos x's derivative is minus sin x. So divided by cos square x. This is nothing but cos square x minus minus will become plus. So this will become sine square x whole thing divided by cos square x. Interesting. Sine square plus cos square is 1. So it will become 1 by cos square x. 1 by cos is sec. So this will become sec square x. That is the answer. So derivative of tan x is sec square x. We got it using the quotient rule or the division rule. Okay, clear? How to use the division rule, how to use the multiplication rule, how to use the addition rule, subtraction rule, and what to do if there is a constant. Just bring that constant outside. Just bring that constant outside. Okay, so many things we have seen. Next rule is going to come up on your screen now. Next rule is going to come up on your screen now. Let's see what that next rule is. This is called as the chain rule. This is called as the chain rule, used in many problems. In fact, before going to the chain rule, let me show you another rule. If derivative of f of x is, let's say, g of x, then derivative of f of ax plus b, this is also called as ax plus b rule, ax plus b is g of ax plus b, but that a will come outside. But that a will basically come outside. That's all. So this is called as the ax plus b rule. Let me demonstrate this to you with an example. Imagine I want to find the derivative of sine of 3x plus pi by 3, okay, or pi by 4, something like that. This is sine's derivative, but not sine x's derivative. There is some ax plus b. Do you see that ax plus b form is there? So whenever you see ax plus b form, use this method. What does this method say? If derivative of a function is something, you find that derivative, just multiply it with the coefficient of x. What is the derivative of sine? Cos. So just simply write cos of 3x plus pi by 4 like you would do normally. But multiply this entire thing with the coefficient of x, which is basically 3. So this is the answer. That is what this means. That is what exactly this means. Understood? Let's take one more example. Don't worry. Imagine I want to find the derivative of log of, let's say, 2x minus 3. What will you do? Usually you know the derivative of log x, but instead of x you have ax plus b form. So okay, what is the derivative of log x? 1 by x. So normally do the mathematics. So it will be 1 by this entire term. Treat this only like x. Treat this entire thing by x. So 2x minus 3 will come below. What is the coefficient of x? It is 2. So multiplied by 2. Hence the answer will be 2 divided by 2x minus 3. That is the answer. That is the answer. Got it? How to use this rule? Many teachers, many books might be writing this, but you need to understand it also. Some people try to skip this and try to do this via chain rule. I do not appreciate chain rule every time. Instead of chain rule, use this ax plus b rule. Makes your job very, very simple. Life is easy with this. We'll be solving more problems. Don't worry about it. I just told you the rules first, then we'll go to mixed problems. Sixth rule is the chain rule. Sixth rule is basically your chain rule. What is this chain rule? What is this chain rule? Okay, let me tell you this. Chain rule, actually first let me write it down, then I'll explain with an example. If you have dy by dx, that can be written down as dy by dt, any variable, dt by d, let's say a, into dA by dz into dz. It's up to you when you want to stop. Let's say I decide to stop now, then stop it over here. Notice one thing. This was, let's say, dy. Let's say this was dx. Dy is only there over here and dx is only there over here. Rest everything else is like a chain. Rest everything else is like a chain. The first term is here, the last term is here, and after that what you have is a chain. You go down like this and go here like this. Go down over here like this, go over here like this. Go down over here like this, go over here like this, and you can stop at any given point of time. So there is like a chain of events which are happening. If you divide by time, multiply by time. Divide by a, multiply by a. Divide by z, multiply by z. Anyways, it cancels out. What is remaining is just dy and dx. This is basically called as your chain rule. As simple as that. Now, how to use chain rule? What are the typical applications of it? Observe this carefully. Observe this carefully. Imagine a situation. Imagine a situation like this. I want to find the derivative of sine of x, but with respect to t. Please understand, you cannot differentiate this. You cannot differentiate x with time. If there is x, there should be x. If there is t, there should be t. This, you cannot write it as cos of x. It's invalid. It is invalid. Understood, my dear students? It is invalid because you are differentiating x with respect to time. Oh, so what to do? Use chain rule. This is like y, this is like x. What I can write it down as, what I can write it down as is derivative of sine of x. Differentiate it with respect to x. This I know. Because I divide by x, I have to multiply it by the same thing. And dt, just leave it as it is. Leave it as it is. This value I can calculate. So derivative of sine of x with respect to x is cos of x. Dx by dt, I leave it as it is. Later on in physics, you will learn that dx by dt is actually velocity, and then you can write it as v times cos x. Okay, derivative of x with respect to time is velocity, and immediately you will convert it in that form. So that is how you use chain rule in problems where the variable with respect to which you are differentiating only is completely different. The variable only is completely different. Okay, clear? Shall we go ahead? So these are the basic rules. Let me just put them up for all of you as a slide over here. Just take a moment to look at all the rules over here. Just take a moment to look at all the rules over here. Okay, all these rules are here. Derivative of constant, derivative of uh, addition, subtraction, then constant, product, quotient. These are standard rules. Then the formulas are mentioned over here. X raised to n x raised to n minus 1, sin x, cos x minus sin x, tan x, sec square x, cot x minus cosec square x, sec x tan x, cosec x minus cosec x cot x, e raised to x, e raised to x, a raised to x, a raised to x log a, log x 1 by x. Okay, just take a moment to write down these formulas. These rules we have done it already over here. No need to write it down. Just write it down in your book once. 1 to 2 times at least write it down. I'll wait for a moment. I'll wait for 1 to 2 minutes. What is the derivative of x raised to n, sin x, cos x, tan x, cot x, sec x, cosec x, e raised to x, a raised to x, log x? These are the only derivatives you need to know. No need of inverse trigonometry and complex things. That will not come. That will not come. Okay, just take a moment, write it down quickly. We'll start with problems. We'll start with many questions now. Done? Give me a thumbs up, smash the like button if you're done with it. Okay. Very good. Chalo. So if this is done, all these rules are taught to you. Let's apply these rules, only then you will understand it. Okay. Let's apply these rules. Okay. Let's start with some examples. Here it comes on your screen. If if you want to find the derivative of 3x minus 4 raised to 6, what is the answer going to be? What is the answer going to be? Okay, just try to think about it, my dear students. Okay, this is of the form ax plus b. This is of the form ax plus b. Treat that 3x minus 4 as a single variable. Imagine, had there been x raised to 6, what would you do? X raised to 6 as derivative. You would have written down 6 into x raised to 6 minus 1, which is basically 5. Which is basically 5. That is what you would have written it down as. Do the exact same thing. You know the derivative of anything x variable raised to some number. It is that number multiplied by that variable which is there into 6 minus 1. So it will be 3x minus 4. But since it is ax plus b form, this is that important part 3, which is the coefficient of x. You have to multiply that 3 over here. You have to multiply that 3 outside. So hence the answer will be 18 times 3x minus 4 whole raised to 5. That is the answer. That is the answer. 18 times 3x minus 4 whole raised to 5. Very good if you guys got it. Proud of all of you. Let's go to the next question coming up on your screen. Find the derivative of ln x with respect to t. Find the derivative of ln x with respect to t. Let's see if you guys can figure this out. First of all, I don't think I can proceed directly, because the moment I see x and time over here, I should be very careful. I cannot do that derivative. So I will use chain rule. So d ln x by dx, okay, into dx, and then divide by dt. This is okay. This, forming a chain. Perfectly fine. So hence the answer for this question will be derivative of log of x is 1 by x into dx by dt. Just leave it as it is over here. Just leave it as it is over here. Very nice. Let's go to the next question coming up on your screen. Let's go to the next question coming up on your screen. How about derivative of sine of x square? Sine of x square with respect to x. Think about it. I cannot find the derivative of x square with respect to x also, because I only know if inside is x, denominator also should be x. If this is x square, this should have been x square. Only then it would work. Only then it would work. Yes or no? So I will make it work by deliberately putting x square without changing the equality. How? Look at this. Sine of x square with, sorry, I had to put d over here. I think that d was missing. My bad, guys. Yeah. So that d was missing. So what I will do is derivative of sine of x square with respect to dx square. I have to also multiply to preserve the equality, and then keep that dx from here as it is. Does this look like chain rule which we have used? With respect to x square into x square dx, I have preserved the equality. So now what will happen? I know the derivative of sine of anything with respect to the same thing. It is nothing but cos of that same thing. So it will be cos of x square. Do you guys agree? The first term, if this was y, this is also y. This is s, this is s, this is x, this is x. So same things I can differentiate. So derivative of sine is cos. Whatever was there inside the bracket, put it as it is, because differentiation was with respect to the same variable. What is derivative of x raised to 2? Well, use x raised to n formula. It is 2 into x raised to 2 minus 1. So hence the answer will be 2x into cos of x square. 2x into cos of x square. Got it? Everybody with me? Excellent. Let's go to the next question. Let's go to the next question. If you understood it till here, just look at the problem. Take a moment to appreciate how these kind of questions have to be done. Next question coming up on your screen. Find the derivative of 1 plus x minus 1 by x. Come on. Let's see if you guys can figure this out. 1 plus x minus 1 by x. You have to figure out the derivative of this. There are three terms. So I will split up the derivative and then find the derivative individually and add and subtract them. So I'll find the derivative of 1 separately, find the derivative of x separately, minus d by dx. X is below, so bring it on the top. So it is x raised to minus 1. Derivative of any constant is always 0, so don't even worry about it. Dx by dx cancels, it becomes just 1, minus, here this minus 1 will come as it is, into x raised to minus 1 minus 1. That's it. So this will become 1 minus minus plus x raised to minus 2, which is 1 plus 1 by x square. That is the answer. 1 plus 1 by x square is the answer. Very good, Satyashri. You are very quick in this. Proud of you. Very good. Let's move on to the next question coming up on your screen, my dear students. Come on, let's do this. Find the derivative of 6 sine x into x raised to 6. Okay, just try to find the derivative of 6 sine x into x raised to 6. You can see there are two functions being multiplied with each other, two functions which are multiplied with each other. So you have to use the product rule. Also, you see one constant outside, bring that constant outside and do the rest of the things. So 6 as it is coming outside, first function into the derivative of the second function plus the second function into the derivative of the first function. That's it. So let's see, what do we get? Sine x as it is, derivative of x raised to 6, x raised to n formula, 6 into x raised to 5 plus x raised to 6 as it is, derivative of sine of x is just cos of x. That's it. If you want, you can just take, x raised to 5 as common, 6x raised to 5, and then bracket, you will have 6 sine x, 6 sine x plus x cos x. That is the final answer. That is the final answer of this particular question. Very good. Excellent. Similarly, let's say, for example, you have another question like this. Y is equal to y is equal to t raised to 5. X is equal to sine of t. Question is, find dy by dx. That is the question. Very interesting question, very different kind of question. How are you going to solve this? Y is a function of time, x is a function of t. Find dy by dx. Don't get scared. I'll tell you what. This is again an application of chain rule only indirectly. You can do one thing. You can do dy by dt in the numerator and you can do dx by dt in the denominator. Dt will anyways cancel. It's like chain rule only. Dt will anyways cancel, and this can be done separately. How? I just have to find dy by dt. What is y? Y is t raised to 5. Dx by dt, what is that x? That x is basically just sine of t. So evaluate numerator and denominator separately. That's all. Evaluate numerator and denominator separately. T raised to 5's derivative is 5 into t raised to 5 minus 1. Sine t's derivative is basically cos t. Hence the answer will be 5t raised to 4 divided by cos of t. Divided by cos of t. That's it. That is the answer. Got it? Let's do one more question coming up on your screen. Yes, let's do one more question, my dear warriors. All right, just 1 second. Y is equal to z square and x is equal to root of, sorry, it is nothing but, let's say, ln z. Question is, find dy by dx. That is the question. Find dy by dx. Come on, let's see if you guys can figure this out. It's again very similar to the previous question. Dy by dx, y is function of z, x is function of z. Think about chain rule. Think about chain rule, my dear students. Okay, so if I want to find dy divided by dx, divide y with respect to z and divide x again with respect to z. Evaluate numerator and denominator separately. So this will be d by dz. This will be d by dz of y. Y is nothing but z square upon d by dz of x. What is x? It is nothing but ln z. Okay, this is separate numerator and denominator. A z square's derivative is 2z. Ln z's derivative is 1 by z. So z goes on the top, it will become 2z square. 2z square. That is the answer. 2z square. Very good, Savita, Satyashri. Awesomeness. Proud of all of you. Next question coming up on your screen. Next question coming up on your screen, my dear warriors. All right, all right, all right, all right. Here is the question. Let's see if we can do this. Find the derivative of sine square x. Now, this is the catch. Just some time back, we did sine of x's square. This is sine x's whole square. Completely different. Completely different. This is, sine x's whole things square. What we did some time back was way, way different. Look at this. Where did it go? Somewhere we did it. Not able to find. Here. See, this was sine x's square. That was a completely different problem. Okay. This is completely different. Let's see if you guys can figure this out. What do we do? What do we do in this case? You do not know sine x whole square's derivative. You have to use trigonometry. That's why I taught you trigonometry. Let's use trigonometry, my dear students. Let's use trigonometry. Okay. Uh, is there some formula for sine square? I think there is. Remember, cos 2x is 1 minus 2 sine square x. Do you remember this formula? Cos 2 theta is 1 minus 2 sine square theta. So what will be 2 sine square x? It will be 1 minus cos 2x. So what will be just sine square x? It will be half minus cos 2x, the whole thing divided by 2. So instead of sine square x, put this. Let's see what happens next. Let's see what happens next. Okay. So what do I get is derivative of half minus half into cos 2x. So what I will do, subtraction, that means separate out the derivative of half separately, minus that 2 will also come outside, and just the derivative of cos of 2x. Is that fine? Everyone with me till this point? Cool. Now see, what is derivative of half? Half is a constant. Constant's derivative is always 0, minus half this as it is. Now understand, this is actually ax plus b form. B is hidden. B is hidden by putting a 0. Just look at it. It is ax plus b form. Wow, we know this. Cos's derivative is negative sign, so put a negative sign and that 2x plus b form. Whatever is the coefficient of x, multiplied. So 2 into that. So hence the answer will be negative, negative cancels, 2, 2 cancels. So hence the answer will be basically sine 2x. Hence the answer will be basically sine 2x. 2, 2 cancels, negative, negative also cancelled. Just sine 2x has come up. Yep, sine 2x has come up. And what is sine 2x? We all know sine 2x is basically 2 sine x cos x. 2 sine x cos x. That's the standard double angle formula. Interesting, right? Understood? Clear? Let's go. Let's go to the next question coming up on your screen. Let's see if you guys can figure this out. If you solve this question, I will be super duper proud of you. Come on. Very similar question. Find the derivative of cos square x. Find the derivative of cos square x. Do I know some trigonometric formula with cos square? I think I know the double angle formula of cos. The double angle formula of cos. Hint is that use that hint and solve the problem. Come on. Cos 2x was 2 cos square x minus 1. Take that 1 on the other side. So 1 plus cos 2x is 2 cos square x. So just cos square x will be half plus cos 2x divided by 2. So just exactly do that. Derivative of half plus cos 2x whole thing divided by 2. So what do we get over here? What do we get over here? This is just the derivative of half separately plus that 2 will come outside. It's a constant, and just the derivative of cos 2x. It's actually hidden ax plus b form. It's a hidden ax plus b form. Constant's derivative is 0. Half comes as it is. Cos of ax plus b derivative is minus sine of x. So minus sine 2x plus 0. Okay, perfect. And that coefficient of x comes outside. So 2 into that. So hence 2 cancels. The answer will be minus sine 2x. Minus sine 2x. How many of you got it? Very good. Sir, my comment getting deleted. Wanted to say something. I'm not so sure, Jersey, what you were saying. But if, see, the admins are very strict in Vedantu. If you say something unnecessary, disrespectful. Fine, you say teaching is bad, no problem. Nothing. Nobody will say anything. You say, I'm a very bad teacher, no problem. But if you say something, I'm not able to understand, that's fine. But if you say something derogatory against me or any of our teachers or anything against Vedantu, then 100% you will be blocked. Okay. There is no denying that fact. And there is no thing like, not just in YouTube, but even in our platform. Okay. We do not tolerate. There is zero tolerance towards any negativity or anything which is not related to studies. If you unnecessarily try to divulge, that's it. It's very simple. They have a very simple policy. Anything which is derogatory, which is uh, disrespectful, which is not relevant and unnecessarily spam, or which is false, straight away block. Okay, it's not like, okay, we'll see and do and this and that. Very simple. Okay. All right. Jersey, don't spam like that, or else again the admin will block you. You put whatever you have to in one line. Don't put one word, one chat. Again, the admin will block you. Okay. So, this is also done. This is also done. Okay, let's see. One more question. One more question. My dear warriors, let's do one more question. D by dx of sine of x by x square. Sine of x by x square. Come on. Let's see if you guys can figure this out. Sine of x by x square's derivative. This is a division quotient rule. So what I will do, use the technique. First, take the denominator and square it. Then take denominator and take the derivative d by dx of sine of x minus. Then take the numerator sine of x into derivative of basically x square. That's all. That's all. Okay, let's see what do we get. We'll get x square. Derivative of sine of x is cos of x minus sine of x into derivative of x square is basically 2x. The whole thing divided by x raised to 4. So I think we will get cos x by x square minus 2 sine of x divided by x, and x raised to 4 will cancel. I'll get x cube. That's it. So cos x by x square minus 2 sine x by x cube. That is the answer. How many of you got it? Wow, some of you have got it. Very good. Very good. Very good. Very good. Proud of all of you. Now that you have understood it till here, oh, by the way, let's now see the next concept in derivatives, which is useful in some problems, which is the concept of maxima and minima. What is this concept of maxima minima? Let me tell you that. Okay, and then we'll put an end to this class and we will do integration in a separate class. Okay, so actually the thing is, I thought I will do everything in 2 hours, but then I went slow. deliberately because I wanted everybody to understand it properly. So I took up a lot of problems just for your sake. So I thought, why not keep a separate class for integration? Okay with it? Put up a heart. Okay with it? Separate class only for integration? Yeah, let's do that. Okay. So let's see properly now what is maxima minima. What is this concept of maxima and minima? So what is the meaning of maxima and minima? There's nothing like that. Long line statements are not getting deleted. Don't do all these things. Okay. So see guys, maxima means the peak of a mountain. Minima means the valley inside a mountainous region. So look at this mountainous region. Do you see there is a peak over here? Do you see there is a peak over here? Do you see there is a valley point over here? Here, here. In fact, there is another peak point over here. These green ones, they are called as maximas. They are called as maximas. They are called as maxima. This is your peak. This is your peak. These valley points, these valley points, these valley points, they are called as minima. Maxima, minima. Now, a lot of people think maxima is maximum, minima is minimum. Let me prove this to you that maxima is not maximum and minima is not minimum. Just imagine this. Just imagine this particular graph. And let's say the graph goes like this. It starts from here, it goes like this, and it ends over here. Okay, this graph ends over here. If I ask you, what is the minimum value of the function? What is the minimum value of the function? Then you will be like this. This is the minimum point. This is the least value. Minimum, I think too many mums happen. Minimum value of the function, correct? And if I ask you what is the maximum value, then this would be the maximum value of that particular functions in that graph. If I ask you what is the maxima, maxima is here. This is the maxima. If I ask you where is the minima, then this is the basically minima. So minima may not be minimum, maxima may not be maximum. So please get it very straight in your head. Okay. So a lot of people think, these two are the same, but clearly over here, I've shown you the distinction. In fact, think of maxima as the maximum value in this locality. Think of minima as the least value in this locality. Like you have a local gunda. You have a local gunda. Think of it like that. So this is like a local gunda. This is like your local gunda. This is your local gunda over here. Okay, this is your local gunda. Okay, he is a don in this area. But who is the real don? Who is the real don? The real don is your Shreyas sir. The real don is nothing but your Shreyas sir, right? Your cap. I'm just putting a cap to show cap. Yes, cap. So that is your capto saying like yo types. Okay. So this is the real don. This is like a local gunda. I hope this is clear. Everybody understood the difference between the two? Great. Now, how do you identify between the maxima and the minima points? Let's come to that now. Let's come to that. It's very straightforward. Okay. So whenever you have a graph, and you are looking at a maxima point or you are looking at a minima point, one thing is common between both of them. One thing is common between both of them, and that is at both these points, if you draw a tangent, the tangent is parallel to the horizontal. So you can see that if I draw a tangent over here, or if I draw a tangent over here, the slope is zero. The slope is zero. So be it maxima or be it minima, the necessary condition, very, very important. the necessary, the necessary condition, the necessary condition is, what is that necessary condition? Dy by dx has to be 0. Okay, the slope has to be a big fat 0. Without that, it can't be a maxima or minima. Before going ahead, first I will check whether you have got maxima, minima, the slope is 0. It's just like if you want to get into government college, what is the first necessary thing? You have to clear the NEET cutoff. Undeniable fact. Just because you have cleared the cutoff, does it mean that you will get a government medical college? No, right? Same way, if you want to see if it is a maxima minima, you will see whether the slope is 0. After that, we can see other conditions. Oh, for government medical college, this. For private medical college, this. So there will be criterias after that. So the next criteria comes over here. So that next criteria comes over here. So the criteria for deciding, the criteria for deciding, like how you decide a college, for deciding a maxima versus minima. Maxima versus minima is as follows. For maxima, the second derivative should be negative. For minima, it's exactly opposite. And the criteria for a minima is the second derivative. When I put 2, it is second derivative. The second derivative should be positive. The second derivative should be positive. Now, what is the meaning of this first derivative and second derivative? Let's probably take it with an example. Okay, let's probably take it with an example. See, imagine if I ask you, example, y is equal to sine of x. If I write dy by dx, it will be like, okay, derivative of sine of x, which is nothing but cos of x. But if I put d square y by dx square, it is the derivative of the derivative. So already I found the derivative. So it is just the derivative of cos of x. So it is minus sine x. I can go a step further and I can find the triple derivative. D cube y by dx square is the derivative of the derivative of the derivative, which is minus common, just the derivative of the sine of x, which is nothing but cos of x. I can go again ahead and I can find any nth order derivative. So another example of second or third order derivative. Imagine, imagine the question is like, y is equal to x raised to 5. Find d square y by dx square. Find d square y by dx square. Okay, that is the question. So first things first, let's find dy by dx. dy by dx is nothing but the first derivative of x raised to 5, which is 5 into x raised to 5 minus 1, which is 5 into x raised to 4. The next step, to find the next derivative, you will find the derivative of this, which is 5 into x raised to 4. 5 comes outside, x raised to 4's derivative, 4 comes outside, x raised to 4 minus 1, which is 5 4s are 20 into x raised to 3. So 20x cube is the answer. 20x cube is the answer. Similarly, if I ask you, come on, find the second derivative of log of x. Find the second derivative of log of x. No issues. Let's find first the first derivative of log of x. The first derivative of log of x is just 1 by x. The second derivative of ln x will be just the derivative of 1 by x. The derivative of the derivative. Take that x value on the top, it will become x raised to minus 1. X raised to minus 1 is x raised to n form. Put minus 1 outside. X raised to minus 1 minus 1. So it will become minus 1 into x raised to minus 2. Bring it down. So it will become minus 1 by x square. So the second derivative of log of x is minus 1 by x square. This is how you find the second, third, fourth, anything derivative. Okay. This is very, very simple. If you know simple derivatives, it's just doing the process multiple times. So the process to find maxima and minima is you just find the first derivative, check, whether dy by dx is 0. And the next criteria, just like how you decide which college I might get, is check the second derivative. If it is negative, it is maxima. If it is positive, it is minimum. It's opposite. A lot of people think minima means negative, positive means maxima. No, it's exactly opposite. Let's take an example to figure this bit out. Let's take an example. Imagine I will take an example. Y is equal to x square minus 2x plus 4. Find if any maxima or minima exists. Find if maxima or minima exists and find those values. Okay, so let's do this. This is some function. What will I first do? I'll check the slope. The slope has to be 0. So that is my first step in that problem. So the slope must be 0. That is the first criteria. So dy by dx, which is derivative of x square minus 2x plus 4. This has to be 0. Okay, so it is nothing but 2x minus 2 plus 0. Correct? Makes sense? X square's derivative is 2x raised to 1. 2 into x. X's derivative is 1 only. Plus 4 is a constant. Constant's derivative is 0. So hence, I will get 2x minus 2 is 0. Solving this further, take that 2 over here. That is 2x. Therefore, x is equal to 1. What it tells you is the slope is 0. The slope is 0 at x equals to 1. It could mean both of these things. Either it is like this 0 or it is 0 like this. Now, I don't know whether it is a maxima at 1 or minima at 1. Both the cases, I know that answer will be 0 if I find the slope. So, to decide whether it is a maxima or minima, what I will do is do the next step. So the next step of the problem is second derivative. So d square y by dx square. Do you see this was the first derivative? If you notice this particular thing, this itself was your dy by dx. This was your first derivative when I found it out. So you have to take the derivative of this. You have to take the derivative of 2x minus 2. 2x minus 2. Okay. What is the derivative of 2x minus 2? It will be 2. X's derivative is 1. So 2 into 1. Constant's derivative is 0. The best answer that I get is 2. Oh, interesting. This 2 is positive. If it is positive, means you don't even have to check anything. You don't even have to do anything. If the answer is positive, it implies it has to be a minima. The only thing which is there in the problem is a minima. There is no maxima only in the question. So hence, there is a minima at x is equal to 1. We found the point, but where is that point? At x is equal to 1. Got it? Everybody with me? Exactly. Let's take one more question so that you guys understand it properly. Let's take one more question so that you understand it properly. Let's say the question goes like this. Y is equal to x into x minus 1 into x plus 1. Okay, this is the question. Okay, and I want to find if there are any maximas or minimas in this particular graph. Okay. Now, first things first, there are many terms over here. So maybe first thing I will do is expand it before doing anything. So therefore, I'll just expand it. So it will be x into a plus b, a minus b is a square minus b square. So x square minus 1 square, and multiply it further. X into x square is x cube. 1 into x is just x. So this is the actual function. This has been factorized into these three factors. That's all. Okay, perfect. So let's just find the first derivative. So dy by dx, how much will it be? It's just the derivative of x cube separately and subtract it with the derivative of x. So x cube's derivative is 3x square. X's derivative with respect to x is 1. Also, simultaneously, let's find out the second derivative, d square y by dx square. So you just have to find the derivative of 3x square minus 1. So it will be nothing but 3. X square's derivative is 2x minus 1 is a constant, so derivative is 0. So it is basically 6 times of x. So this is your second derivative. Oh, this could be positive or negative, depends on many factors. So do you see that? It could be positive or negative, depends on the value of x. So I do not know that yet whether it is a maxima or minima. Okay, no issues. Let's continue over here. Imagine for it to be maxima or minima, the essential condition is this dy by dx must be 0 for the maxima or minima. This is the most essential. This is necessary condition. This is necessary condition. So if I rearrange it, 1 will be equal to 3x square. That means x square will be 1 by 3. That means x will be plus or minus 1 by 3. So two values are I am getting 1 by 3 and minus 1 by 3. At one of these points, maybe there is maxima. At one of these other points, maybe there is a minimum. But I know at 1 by 3, slope is 0. Minus 1 by 3, slope is 0. So at these 2 points, the slope is 0. Everybody with me? Everybody understanding it till this point? At 1 by 3 and minus 1 by 3, the slope is big fat 0. That is what this is telling me. That is what this is telling me. Okay, so what I will do now, I will substitute both these values over here. I'll substitute 1 by 3 here and I'll substitute minus 1 by 3 over here and see what is the value of the second derivative I'm getting. 6 into 1 by 3, 6 into 1 by 3 is basically 2. 6 into minus 1 by 3 is minus 2. This is positive, this is negative. It is very, very clear now what is happening. Negative means maxima. So there is a maxima at x equals to minus 1 by 3. Also, I get to know because this is positive, there is a minima, at x is equal to plus 1 by 3. Don't worry about these values. These values are nothing. Just you have to check the sign of it. This is 1 by 3 minus 1 by 3 are those values of x at which I'm getting maxima and minimum. All we did was check, okay, this was more than 0, this was less than 0. That's how you find maxima and minima. Clear? So a lot of you said 2 and minus 2, guys. 2 and minus 2 is not maxima. Please get that right. 2 is not maxima, minus 2 is not maxima. That is the value of the second derivative. Second derivative's value is what I'm getting. You just need to check whether it is positive or negative. If it is positive, the value that you have substituted is the location where you get the minima or maxima. Got it? So that is a common mistake which many students do. That is the reason why I did this question. All right. So let's begin with the class. Now, see guys, when I say I want to find the derivative, or differentiation, or basically the rate of change, or basically instantaneous value, or basically the slope. We used to be given a function like y is equal to, let's say, a function, then dy by dx, which is f dash of f dash of x used to come out to be some new function like g of x. For example, for example, if if y was sine of x, then derivative of sine of x with respect to x was a new function which was cos of x. That's what it is. So that is what derivatives used to stand for: instantaneous value, rate of change, slope, etc. Now let's go exactly opposite, which is basically antiderivative. And this antiderivative process, which is the exact reverse process, is basically called as integration. So let me give you a couple of examples and let's see what your answer is. Imagine I told you there is a magical box whose job is to differentiate. So it basically takes derivative, whose job is to basically take derivative. And I give input, it gives me the derivative of it. Say for example, the input that I give is x cube. The output that I get is the derivative of x cube, which is nothing but 3x square. Is nothing but 3x square. Now, I tell you that listen, there is another magical box. There is another magical box. And let me call that magical box as integration, whose job is the exact opposite of derivative. So antiderivative, antiderivative. So meaning, if you give it something as input, it will tell you whose derivative was it. If you give it some input, it will tell you whose derivative was it. So say for example, if I put an input of 3x square, what should the output be? You will think whose derivative is 3x square? Well, it would be x cube's derivative. Well, it will be x cube's derivative. Are you getting it? So I can say that the antiderivative of 3x square or the integration of 3x square is x cube, meaning I just have to think reverse, whose derivative is 3x square. Well, that's x cube. In this case, the job was quite simple. In case this job was quite simple. Everyone with me? Cool. Now I have a problem over here. The problem is as follows. If I ask you what is the derivative of x cube plus 4, well, if I put that as the input, still I will get the output as 3x square. Okay. What if I put the input as x cube minus 7? If I give that as the input, still the output is 3x square. Reason is the derivative of the constant term will be 0. The derivative of the constant term will be 0. So in general, if I put x cube plus some constant, the answer is still going to be 3x square. The answer is still going to be 3x square. So when I go reverse and I ask you whose derivative is 3x square, I will be like, listen, 3x square is a derivative of x cube, but maybe there could have been a constant inside the function, and maybe if that constant existed, the derivative would have become 0. So it is not seen over here. It's just not seen here, but it could have been present. This constant is called as the constant of integration. This is called as the constant of integration. Now probably you understand why this constant of integration comes, is because whenever the original function would have a constant, the derivative would be 0. So there was no way of knowing whether that constant was there or not unless it was told to you or the truth was revealed to you. So because while going reverse, I would never know about it. There was no way for me to know about what the original function looked like. That is why, as a benefit of doubt, we just put a C so as to tell that, listen, there could have been a constant. Is that right? Everybody with me on this? Clearo? Perfect. So now, similarly think, if I ask you, listen, there is this magical box whose job is to differentiate, and I give it to it an input, let's say sine x. The output of that would be nothing but cos of x. Not just that, if I put sine of x minus 6, the output will still be cos x. If I put sine of x plus 0.689, still the output would be cos x. In fact, sine of x plus constant, the output would still be cos of x only. That means if I go exactly the reverse way and I say I want to integrate, and then I ask you, listen, what is the integration of cos of x? You have to think, whose derivative? Whose derivative is cos x? Well, it could be sine of x plus constant. Sine of x plus c is the integration now of cos of x. Is that clear? Everyone with me? So now you understand how to find the integration of any given function. You just have to think reverse, but also add the benefit of the doubt, which is the constant of integration. Now we all know that when we study derivatives, we can say it while telling it to someone or in words, derivative of something, differentiation of something, rate of change of something. But mathematically, symbolically, how do you write it? dy by dx. So if I were to say that integration or antiderivative, all right, is in words, or while telling somebody that I want to find the integration of 3x square, I want to ask what is the antiderivative of 3x square. This is in words while telling to someone or describing a problem. Is there a symbolic way of doing it? The answer is yes. So let's see what the symbolic way of doing it is. Let's see what the symbolic way of doing it is. So say for example, I want to integrate 3x square. I want to ask you what is the integration? What is the integration of 3x square? Symbolically, what you will do is you will put 3x square. I want to find the integration of it. There is a symbol of integration which looks something like this. It's like a long line, slightly S-shaped. Okay, slightly S-shaped like this. So this is basically your symbol of integration. This is your symbol of integration. This is your symbol of integration. Just like you used to differentiate it with respect to x, derivative with respect to time, rate of change with respect to z. Same way, you also integrate it with respect to something. So maybe I can just say, dx over here. So this is integrated with respect to. This is integrated with respect to. Integrated with respect to what variable? So if there is x over here, I will always integrate with x. If there is z here, I will integrate it with dz. If there is t here, I will integrate it with dt. So these two variable types should be the same. Otherwise, you can't integrate. Just like you can't differentiate sin x with respect to dt. You have to use chain rule and all of that. So integration also works the exact same way. And then comes the final outcome. And then when I say it is x cube, this is basically the antiderivative. This is basically the antiderivative or the final integration of this. And obviously, you will have plus c over here, which is nothing but the constant of integration. The constant of integration. That is how the symbols and other things work. Integration symbol with respect to something, this is whose derivative will give me 3x square, and then a benefit of the doubt, which is the constant of integration. So if I go back over here and I ask you, symbolically, can we write this? The answer is yes. Symbolically, if I had to write it, I would write it like this: cos of x. I want to integrate it. So integral like this. With respect to what? With respect to dx. With respect to dx. Then I will get the final answer. What is the final answer? The final answer is sine of x. And yes, there is a constant of integration, which is plus c. So this is how I will write this problem in words, or which I had described, okay, or this diagram. I'll convert it into a mathematical, symbol or equality. Is this part clear? How the symbols work? What is a symbol? What is constant of integration? What is dx? And what is the meaning of integration? Till this point, everybody clear? Give me a thumbs up, smash the like button so that I can see you have understood it till this point. Everybody clear? Oh, awesomeness. Awesome. Great. So now let's see if you guys can figure out few more things. Let's see if you guys can figure out few more things over here, and let's play with it a little bit. If I just ask you, what is the integration of, what is the integration of cos of x dx? Think this way, whose derivative is cos x? Think like this, whose whose derivative derivative is cos x. Think like that. That will be a better way of solving the problem. Well, if I differentiate, sine of x, if I differentiate sine of x, right, with respect to with respect to x, with respect to x, I will basically get cos of x. I'll basically get cos of x, correct? So that means differentiating sine will give me cos, so integrating cos will give me sine. So hence integration of cos of x must be sine of x plus c. Sine of x plus c. Similarly, if I ask you what is integration of sine of x dx, sine of x dx, think whose whose derivative or differentiation is sine of x, whose derivative is sine of x. Well, if you differentiate cos x with respect to x, what you get is negative sine x. What you get is negative sine x, but here I don't have a negative symbol. So what if I took the derivative of minus cos x with respect to x? Well, this minus and this minus would cancel, and I will just get sine of x. Is that right? So if derivative of minus cos is sine, hence the integration of sine should be minus cos. Hence the correct answer for this particular problem should be nothing but minus cos. Should be nothing but minus cos x. Is that absolutely clear, my dear warriors? Excellent. Similarly, my dear students, if I ask you what is the integration of e raised to x dx, you will think whose derivative is e raised to x. Think whose whose derivative is e raised to x. Well, e raised to x's derivative with respect to x is again e raised to x. So if the derivative is e raised to x, the integration will also be e raised to x only. Hence the answer will be e raised to x plus c. E raised to x plus c. Everybody understood till this point? Awesomeness. What if I ask you what is the integration of 1 by x dx? 1 by x dx. You will think whose derivative is 1 by x? Well, if I take the derivative of log of x, you remember this formula? The answer is 1 by x. The answer is 1 by x. So derivative of log x is 1 by x. Integration of 1 by x is log x. Hence the answer to this problem will be ln x plus the constant of integration, which is the benefit of the doubt. Exactly. Proud of all of you. Amazing. Amazing. So this is how it goes. Now, if I ask you, think about it, what will be the integration of x raised to n dx? X raised to n dx. This is a slightly tricky problem. This is slightly tricky problem. What will be the integration of this? Think whose derivative will give me x raised to n. If I take the derivative of x raised to n with respect to x, what I get is n into x raised to n minus 1. Well, this is not exactly what I want. Okay, let's first of all shift n on this side, because answer should only have x raised to n over here. Derivative of this gives me this. I don't want to integrate this. I want to integrate x raised to n. Let me do one thing. What if I do x raised to n plus 1's derivative? X raised to n plus 1's derivative will be n plus 1 will come outside, x raised to n plus 1 minus 1. N plus 1 minus 1 is n only. Is this what we get? Oh, interesting. Shift n plus 1 below. Shift n plus 1 below. So it will become d by dx of x raised to n plus 1 divided by n plus 1. This whole thing is giving me x raised to n, which means the derivative of this is x raised to n. So the integration of x raised to n should be this. Is that clear? Everybody? Awesome. Awesome. Namrata, understand, no question in NEET has been ever asked to just differentiate or integrate. It's always a part of other problem or other chapter or other topic. It's like derivatives will be used in Faraday's law, it will be used in kinematics, it will be used in Newton's laws. So over there you are going to find the use. So you will not find PYQs. So, oh, find the log of this. It's not there in physics. You open up any PYQ, it is not there. Correct? So hence the answer to this question will be, well, derivative of this was x raised to n. Integration of x raised to n will be x raised to n plus 1 by n plus 1, benefit of the doubt, which is plus c. That's how I write it. So the same thing you can apply it for other things also, and we get the formulas of integration, which I think I have put over here. Let's have a close look at it. In fact, before showing you that formula, one last formula also I can show you. What is just integration of dx? Just think of it like this. Integration of dx means, integration of dx means integration of 1 dx. Integration of 1 dx. Now think whose derivative is 1. Think whose derivative is 1. Well, if I differentiate x with respect to x, the answer is 1. So derivative of x is 1. So integration of 1 will be x. Hence the answer to this problem, is just x, and put that constant of integration. So integral dx just becomes x, and that c will come as it is. Excellent. Awesome. Yep. Yep. So now, my dear warriors, let's have a look at these formulas. Most of these formulas, you will not even use. Only basic formulas you will see in NEET physics. But on the safety net, as a safety net, we need to just have a look at all the formulas. I just showed you integration dx is x plus c. Integration x raised to n is x n plus 1 upon n plus 1. E raised to x's integration is e raised to x. A raised to x's integration is a raised to x by log a. Log x's integration is x log x minus x. Sin x's integration is minus cos x. Cos x's integration is sin x. Tan x's integration is minus log cos x. Cot x's integration is log sin x. Sec x's integration is log sec x plus tan x. Cosec x's integration is cosec x plus cot x is log with minus sign. Sec square integration is tan. Cosec square integration is minus cot. Sec tan's integration is sec. Cosec cot integration is minus cos. Now it looks very lengthy and tedious at the beginning, but to start with, I would say just remember only these formulas. This one, this one, this one, this one, this one, this one, and yep, I think this should be enough. For starters, 1, 2, 3, 4, 5, 6. These 6 formulas, write it down 2 to 3 times in your book, in your page, in your rough sheet, whatever you are using right now. Just these 6 formulas. 1, 2, 3, 4, 5, 6. 6 formulas. You please write it down at least 2 to 3 times, and once done, put up a heart in the chat box. And those of you are done, you can write down these other formulas at least 1 time to 2 times so that it enters your head. Generally speaking, you never use these formulas. Even in JEE physics, very rarely these formulas come. So that is the reason why I'm telling you these formulas are must. These formulas are not optional, but you can remember it at a later point of time once you're comfortable with these formulas. Okay. Yes, there is hostel facility in offline. In Bangalore, we have. In some other places also, we provide those tie-ups for offline facilities. Definitely. Yep. All righty. Awesomeness. Great. Done. Very good. Chalo. Now that you are done with this, let's have a look at questions and how do we solve them. All the different kind of things. Once done, put up a heart. All these 6 formulas, write it down couple of times. It's very simple. See, e raised to x integration is e raised to x because derivative of e raised to x is also e raised to x. Sine's derivative was cos, so sine's integration is minus cos. Only the sign is different. Cos's derivative was sine, so cos's derivative was minus sine, so cos's integration is plus sine. That's the major difference. Very easy to remember these two. And this one, 1 by x is also very easy because log x's derivative was 1 by x. So integration will be log x. This is also simple. Integration dx is x. Very simple. This formula, with practice, you will get it. X raised to n's integration is x raised to n plus 1 by n plus 1. Okay. This is a only different looking formula, but I think with practice, you will get used to it. The others, don't worry. Once you understand how to use it, rest is just formulas. You just have to write it 5 times, 10 times, 20 times. That's it. But very, 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 very low chance of you getting a question on these. Let's have a look. In fact, you can open up PYQs also and see how many times they have asked even a question on integration. That is only rare. Okay. So 1 or 2 questions do come in the entire NEET physics paper of integration, but you cannot say I will not do it, because then understand you will start leaving many more things. Okay. You will start giving excuses for so many things. Likewise, you take any chapter, how many questions will be asked? 1 or 2 questions. So then you'll say, I'll leave this chapter also. Then you'll be like, okay, I'll leave ray optics only. Anyways, 1 or 2 questions will come. So that way you'll end up leaving the entire syllabus. All right. Okay. So let's start with some questions. Okay. Let's see. What is the integration of x raised to 4 dx? Let's see if you guys can figure this out. Integration of x raised to 4 dx. This is x raised to n formula. This is x raised to n formula. So here n is 4. So what is the formula? It was n plus 1 on the top and n plus 1 below also. So you raise the power by 1 and also divided by the increased power. Do not forget that plus c. So hence it will become x raised to 5 divided by 5 plus c. That should be the answer. Just check this out. X raised to 5 by 5. Very good. Excellent. Moving on. What is root of x's integration? What is root of x's integration? First of all, root of x is nothing but x raised to half dx. X raised to half dx. Now it becomes easy. So half plus 1 upon half plus 1 plus c. So half plus 1 is 3 by 2. So x raised to 3 by 2 by 3 by 2 plus c. So 2 goes on the top. So 2 by 3 x raised to 3 by 2 plus c. That is the final answer. That is the final answer. 2 by 3 times of x raised to 3 by 2. Very good. Excellent. Moving on to the next question coming up on your screen. 1 by x cubes integration. 1 by x cubes integration. You cannot do it directly. You have to bring it on the top. Okay, always, just like in derivatives, always bring it on the top. So it will be x raised to minus 3's integration with respect to x. Now this is doable. This minus 3 is like n. So it will become x raised to minus 3 plus 1 upon minus 3 plus 1. I'm just using this formula. X raised to n plus 1 upon n plus 1. That's it. And do not forget that plus c. So this will become x raised to minus 2 upon minus 2. So take that minus on the top. So minus 1 by 2. And this will become x square. And obviously plus c is there. So minus 1 by 2 x square. The whole thing plus c should be the answer. Okay. I hope this is clear. Awesome. Awesome. Very good. Shall we go ahead to the next one coming up on your screen? All right. Let's do this. Let's do this, my dear students. Integration of 1 by x dx. What is the answer? Integration of 1 by x dx. A lot of people are going to probably think of this. Let me take x raised to minus 1 like this dx. So now when you start applying the formula, what you will get is x raised to minus 1 plus 1 upon minus 1 plus 1 plus c. So this will be x raised to 0 upon 0 plus c, which can't be possible. You cannot divide any number by 0. So keep this in mind. You cannot use this formula only for a special value, and that special value is n is minus 1. So this is only valid as long as n is not equal to minus 1. Because when n is minus 1, then you will go to this formula. When n is minus 1, you will go to this formula. It will just become log of x. So do not do it like this. The answer to this question is direct ln x plus c. You cannot use this formula when n is negative 1. Is that clear? Everybody with me? That's why I put this note over here. N should not be minus 1 for using this formula. But if n is minus 1, then you go to this formula. Okay, perfect. Great. Let's move to the next question coming up on your screen. integration of 1 by root x dx. Integration of 1 by root x dx. Come on. X's root is basically 1 by x raised to half dx. Take that half on the up, so it will become minus half. That's what the actual integration to be found. So minus half plus 1 upon minus half plus 1. So minus half plus 1 is plus half. So it will become x raised to half upon half plus c. 2 goes on the top. 2 goes on the top. So 2 into x raised to half plus c. But anything raised to half is root. So 2 root x plus c is the answer. So 2 root x plus c is the answer. Very good, Satyashri. So many of you got it. Yeah. Okay. Very good. Excellent. Now that you have understood it till here, and now you understand that, okay, if I just know the formulas, I mean, most of the job is done. Cool. So, are there any addition, subtraction kind of rules that we have over here? The answer to that is yes. The answer to that is yes. So, let's have a look at those kind of rules or those kind of, you know, or whatever properties are there. The first rule is basically of addition and subtraction. Okay, let's see what it is. Very simple. So for adding or for subtracting, what is the rule? It says that if you want to integrate a function plus another function or subtract it with respect to dx, then you do one thing. You integrate those functions separately, and then you add or subtract accordingly. It's just like derivatives, nothing great about it. So, my dear warriors, imagine if I had to integrate e raised to x plus sine of x, okay, dx. Then I will integrate e raised to x dx separately, and I'll also integrate sine of x separately, and then see what the answer is. E raised to x's integration is nothing but e raised to x only. Sine x's integration is minus cos x. Sine's derivative is cos, so integration is minus cos. Sine will be different. That's all. So it is minus cos x. How many constants should I put? Should I put c1 plus c2, or should I just put c? Should I put c1 plus c2, or should I put c only? Even if I put c1 plus c2, c1 and c2 are just nothing but some constants. If I add, subtract them, what will happen? What will happen? Come on. What will happen? Yes, it will be just another constant only. Very good. So hence the answer should be just C. Hence the answer should be just C. Very good. So don't worry about putting C1, C2, C3, C4 like that. It's a waste. Complete waste. Yep. Okay. So just put it as one single constant. Similarly, I can give you one more example. Integral of 1 plus x square or 1 minus x square dx. If I want to do this, separate out the integration. So 1 into dx is just dx minus integration of x square dx. What is the integration of dx? I told you integration of dx is just x, and x square's integration is x raised to 2 plus 1 by 2 plus 1 and plus c. So hence what will be the answer? It will be x minus, it will be x raised to 3 divided by 3 plus c. That's it. That is the answer to this particular problem. That is your simple addition and subtraction rule. Exactly. So Akriti, don't worry. Some of the students out, they are not even students. These are basically bots and spammers who come to different channels and basically act as if they are a genuine student, and they try to spam and talk negatively. So don't listen to those kind of people. Okay, because a genuine student will never come like this and ask a doubt. So this is a new level of negative marketing which has been going on from our competitors, and I just got to know that recently a lot of spammers and lot of fake profiles are being sent into different channels which are competitors, so that they can put a negative reviews or they can put something negative about the person, but they will act as if they're a student. There is a separate team which sits. Okay. So for all this, right? So Moving on to the next rule. Moving on to the next rule. What is the next rule? It is basically the constant rule. The constant rule. Very, very simple. The constant rule. Okay. See, guys, if you have to find the integration of k and some function is there, after it, you forget that constant inside the integration. In fact, bring it outside. It will be k times integration of that function with respect to x. As simple as that. So let's take an example for this. Let's take an example for this. Integration of 7 by x dx. That 7 is a constant. Bring it outside. So it will become 7 into 1 by x dx as integration. 1 by x as integration, I already know. It is nothing but log of x and then just put plus c. Then just put plus c. That's it. Yeah. Yep. Akriti, how do I know about it? I also have my friends, no teachers who are there in different places. I also have my sources. I also know many people who work behind the scenes, right? So I have friends. We all talk. It's not like I stay silent or they stay silent. So that's how we know. Okay, cool. Huh. So, my dear students, what if it was, let's say, minus 3 cos x's integration, minus 3 cos x's integration. This minus 3 is a constant, bring it outside. So, minus 3 integration of cos x dx, minus 3 will come outside. Now, cos x's integration, what is it? Well, derivative of cos is negative sign. Integration of cos is plus sign. So, hence, minus 3 sine of x and then plus c. That's how you will write it down. Very good. Excelente. Excelente. Okay, great. Next important rule which you should know. Next important rule which you should know. That is your ax plus b rule. That is your ax plus b rule. If you remember in derivatives, we did this. And in derivatives, I told you if there is ax plus b form, you take the derivative normally, just multiply with the coefficient of x, which is basically a. In integration, also same thing happens. You integrate it normally. Instead of multiplying with a, you divide it with a. That's it. That's it. So let's have a look at it. Say for example, if integration of f of x dx is basically g of x plus c, then the integration of f of x, sorry, f of ax plus b dx happens to be whatever integration you want to do it normally, just that whole thing divided by a, that's it, plus c. That's all. Just divide it with the coefficient of that x and do the integration normally. That is your answer. Let's have a look at some examples for this. Imagine I want to do integration of sine of 3x minus 2. Sine of 3x minus 2. See, normal sine x's integration I know. Sine x's integration I know. This is sine of 3x minus 2. It's of the form ax plus b. Do the integration normally. What is sine's integration? Sine's derivative was minus cos. Sorry, sine's derivative was plus cos. So integration will be minus cos. So the answer will be minus cos, whatever is there inside, which is 3x minus 2. The whole thing divided with the coefficient of x, which is basically 3, and then just put plus c. That's the answer. That is the answer. Cool. Let's do more. Let's do more questions so that you guys get a hang of it. Integration of 2x plus 5 raised to 6 dx. This is of the form x raised to n. Instead of x, you have ax plus b. That a being 2, b being 5. Normally, if x raised to n's integration was asked, what will you do? That x raised to n plus 1 upon n plus 1. This is what you would do. Now, instead of x, what is there? 2x plus 5. Very good. Now, whatever is the coefficient of x, you need to divide it also. So, divide it over here. That's all. So, hence, the final answer will be 2x plus 5 into 7 raised to 7. 6 plus 1, 7. 7 to the 14. So divided by 14. That is the answer to this. That is the answer to this. Everyone Clearo? Perfecto? Shall we go ahead? Pavitra, minus sign will also come. I hope you understood why. Okay, till this point. Let's take next question coming up on your screen. Let's see if you guys can figure this out. Integration of 4x minus 5 dx. Integration of 4x minus 5 dx. Can you see ax plus b form? I think so. You can see x plus b form, ax plus b. Treat that ax plus b like one single variable x. So this is 1 by x's integration. 1 by whole thing x plus b, think of it like x integration. What is 1 by x's integration? It is log of x. Hence the answer to this will be log of x, but that x itself is 4x minus 5 and the whole thing divided by the x's multiplying factor, which is 4, and then put plus c over here. That is the answer to this particular question. Is that clear, everyone? Coolo? Amazing, amazing. So this is your ax plus b rule. This was your ax plus b rule. We saw the constant rule. We also saw the addition subtraction rule as well. Let's start doing some basic questions before we go to some substitution based questions as well. And then definite integration. All right, let's see. Okay, come on, my dear students. Everybody gear up. Questions are coming up on your screen. Integration of root of x plus 1 minus 1 by x dx. What is the answer to this? Next question on your screen is this. Integration of sec x tan x minus cos x plus e raised to x dx is how much? Okay, come on, figure this bit out, everyone. I think everybody can do this. First of all, look at root of x. Root of x is basically x raised to half. So split them up. It is integral of x raised to half dx. Addition sign is there. So plus dx minus 1 by x, you can keep it as it is. This is what exactly this is. What is x raised to half's integration? X raised to half plus 1 upon half plus 1. Integration dx is x. 1 by x's integration is log of x. Do not forget plus c. So this will become 3 by 2. 3 by 2, 2 goes on the top. So 2 by 3. X raised to 3 by 2 plus x minus log x plus c. This should be the answer. 2 by 3, x raised to 3 by 2. Very good. Plus x minus log x. Very good, Krishna. Shushmita. Awesome. Awesome, Satyashri. Great. Proud of all of you. Similarly, try to do this problem. Think whose derivative is sec x tan x. Whose derivative is sec x tan x? Come on. Whose derivative is sec x tan x? We have seen this. Sec x tan x is the derivative of sec x. Sec x's derivative is sec x tan x. So integration of sec tan is sec. Integration of sec tan is basically sec. Exactly. So if you remember derivatives formula, you will get it very simply. So hence the answer to this particular question will be just nothing but sec x. Cos x's integration is nothing but sine of x. So put sine of x. E raised to x's integration is just e raised to x plus c. So direct formula application, nothing great over here. Exactly. Everyone, sec tan's integration was sec, cos's integration was sine, not minus sign. Cos's derivative is minus sign, be careful. E raised to x's integration is e raised to x only. So nothing doing over there. So that problem is also done. Very nice. Let's see if you guys can figure this bit out. Next question coming up on your screen. Now, what is integration of cos 5x? What is the integration of cos 5x? Come on, figure this bit out. Next question coming up on your screen. What is the integration of? What is the integration of? Let's say 2 sin x cos x. What is the integration of 2 sin x cos x dx? Come on, figure this bit out. Not that difficult. Not that difficult at all. What is the integration of cos of 5 of x? Come on. This is of the form ax plus b, like it or not. Yep. This is actually 5x plus 0. where b is 0, a is 5. So you do the normal integration. Integration of cos is plus sign. So it will be basically sine 5x. Whole thing divided by the coefficient of x, which is basically 5, and then put plus c over here. That's it. You have used ax plus b rule. Exactly. Yes, that 5 is not divided inside. Please understand, it is whole of sin x divided by 5. Correct. This is also very straightforward. If you realize some trigonometric formula, 2 sin x cos x is nothing but sine 2x. Is nothing but sine 2x. Exactly. It is nothing but sine 2x. Sine 2 theta is 2 sine theta cos theta. Double angle formula. Now this is of the form ax plus b. So this will be sine's integration. What is sine's integration? Believe it or not, this is actually ax plus b form. 2x plus 0 dx. Correct. So sine's integration is negative cos. So negative cos of 2x, the whole thing divided by the coefficient plus c. That is the answer. That is the answer. Exactly. Can a pure science student follow this lecture? Yes, Shriya, Sanjana, why not? Definitely. I mean, if you're a science student, you should be aware of integration and derivatives, irrespective of whether you're a medical student, engineering, you're a science student. So science involves mathematics. You will need it at some place or the other. Next question coming up on your screen. What is the integration of sine square x dx? Very, very interesting formula. Sine square x form integration we need to do. Sine square x as integration we need to do. Think about it. How do I do that? Sine square integration, nobody taught us. Okay, so we have to use some bit of trigonometry, and I think it is double angle formula, like it or not. So remember, cos 2x was 1 minus 2 sine square x, right? Take that 2 sine square x over here. Take that 2 sine square x over here. It will become 1 minus cos 2x. Therefore, what will sine square x become? It will become half minus half cos 2x. Oh, so sine square x can be written down in a much simpler form like this. So let's substitute it and see what do we exactly expect over here. So first term is basically half. So it will be half dx minus half is going to come outside, and then we'll have cos 2x dx. Just check this out. Instead of sine square, if you put this, so half it will be the first term, half cos 2x will be the second term, but that half is a number, so I have just brought it outside the integration using the constant rule. Okay, I think now this is solvable. In fact, if you don't like this also, I'll just not skip a step. I'll just write it down like this. This is half cos 2x by 2 dx. Now that take that 2 outside, take that 2 outside or half outside. So this is half integral dx. This is half integral of cos of 2x. Instead of 2x, write it as 2x plus 0, so that you see it is ax plus b form. What is integration of dx? It is just x. It is just x. Correct. It is just x. So integration of cos 2x plus 0. Guys, ax plus b rule, use it. Cos's integration was sine, because cos's derivative was negative sign. Cos's integration was plus sign. So sine of 2x, whole thing divided by x's coefficient, which is 2, plus c. Hence the answer will be x by 2 minus sine of 2x divided by 4 plus c. That is the final answer. That is the final answer. Correct. Very good, Pratibha. Herboroin. Evening Star. Yes, very good. Very good. Excellent. Many of you wrote plus. The answer is not plus, the answer is minus, because cos's integration is not negative sign, it is plus sign only. So the minus sign stays intact. Okay, be careful. Be careful over here. Okay, and when I shifted 2 sine square x, it became 1 minus cos 2x by 2. Yep. Yeah, there is no plus there. I think you missed that minus sign. Yep, be careful. There is no plus sign, guys. There is a minus sign in between. Okay, because cos's integration is not negative sign, it is plus sign. Cool. Is that clear? Very good. Excellent. Excellent. Perfect. Now, that we have learned through, where is that formula sheet? We have learned through most of the formulas, all right, or seen how these formulas are applied. Sometimes, very rarely, you might need some kind of substitution, but that is very, very rare. Okay, I'm just showing you an example of this where you might need substitution. I'm just teaching you the method. When that problem comes in physics, you will understand what we have exactly done. Say, for example, I want to integrate 1 divided by 1 plus x square, okay, dx. Example, I want to integrate this. I want to integrate this. Or, 1 minus x square, I want to integrate. Or let's say there is minus over here. Okay, some random equation is there over here. Okay, not minus. Yeah. Now, when I want to integrate this is not any known formula. This is not any known formula. So, in order to make it into a known formula, we substitute x as something so that it becomes a known formula. We substitute x as something so that it looks like a known formula. In these problems where you substitute x as something, the substitution has to be done very smartly and very intelligently, because nobody will tell you you have to substitute x as this, x as that, etc. Nobody is going to tell you that. Rather, that comes via a lot of practice. That is why those problems never really come, in NEET physics. But just for the sake of giving, I'm telling you. So what you do, let's say for example, this is intuitively thinking, what if I substitute x as, example, x as, let's say, sine theta. What if I substitute x as sine theta? Just think about it. What will happen to 1 minus x square? Just think about it. What will happen to 1 minus x square, which is the denominator? The denominator will be 1 minus sine square theta, and 1 minus sine square theta is basically cos square theta. Oh, perfect. So what might happen is, instead of this, I will get 1 by, here I will get probably cos square theta. Here I'll probably get cos square theta. Do you understand it? Right? And maybe, what if there was a root also? If there was a root also, then probably this would be under the root, and root of cos square theta would be basically just cos theta. So all those things can happen. This will only come with practice. The moment I see 1 minus x square, I generally think x can be put as sine theta or cos theta, because 1 minus sine square or 1 minus cos square is the other term. But the problem is, you cannot leave this as a dx, because I cannot integrate theta with respect to x. That is the most common catch. So I need to get rid of this dx also. No issues, we'll get rid of that also. First of all, this, if I had the root in the question, then this would have been just 1 by cos theta. This would have been just 1 by cos theta. What to do about dx? No worries at all. Just look over here, my dear students. Just differentiate this x with respect to theta. Differentiate this x with respect to theta. That means you are differentiating sine theta with respect to theta. Okay, I am differentiating sine theta with respect to theta. What is the derivative of sine theta? What is the derivative of sine theta, my dear warriors? It is nothing but cos theta. Take that d theta on the top. So you will get dx is equal to cos theta d theta. You will get dx is equal to cos theta d theta. Do you see dx over here? Just substitute the dx as basically cos theta d theta. Just substitute that dx as basically cos theta d theta. Perfect. Awesome. So what happens now? Don't you see cos theta and cos theta just got cancelled? Cos theta and cos theta just got cancelled, and what did we have? Just integration of d theta. This is like integration of dx. Integration of dx is just x. So integration of d theta is just theta. So theta plus c. But what was theta? Well, x is sine theta. If x is sine theta, that means theta will be sine inverse of x. Hence, the final answer will be nothing but sine inverse of x plus c. That is the answer to this particular question. Got it? You have to resubstitute it back also. Here we substituted and again get it back into x. You cannot leave the answer in theta because theta was an assumed variable. It was a temporary placeholder. Yep, exactly. This is basically called as a method of substitution. Uh, you don't have to worry about it so much. Only in JEE, that too in a mathematics part, people see these substitution based questions. Even in physics, you won't see these substitution based questions except for JEE Advanced. So need physics, very rare, but still I have told you about it. Okay, still I have just told you about it. So all these kind of things might come, somewhere or the other. So now that you have understood till here, now that you have understood it till here, let's take one more question on substitution so that you are confident. Let's say I do integration of e raised to sine theta into cos theta d theta. Okay, I want to integrate this. I want to integrate this. Okay, looks like a complex integration, right? E raised to sine theta into cos theta d theta. But trust me on this, actually, when you substitute it properly, it becomes a very simple integration. How? Let's think. What would you substitute as? What would you substitute as what? I can see sine theta, I can see cos theta, and I have a rough idea that sine theta's derivative is cos. So I got an idea now. How about substituting x as sine theta? Just think about it. So if I take the derivative of x with respect to theta, it will be like differentiating sine theta with respect to theta. Derivative of sine theta is just cos theta. So dx by d theta is cos theta. Dx by d theta is cos theta. So that means dx will be cos theta d theta. Interesting. Cos theta d theta. Look at this and look at this. How about replacing these people with just dx? Replacing this people with just dx, my dear warriors. And instead of e raised to sine theta, e raised to sine theta, I will just replace sine theta with x. So it is e raised to x dx. Oh, this I know. Integration of e raised to x is e raised to x only. So hence the answer will be e raised to x plus c. But I can't leave the answer as x. I have to get it back into theta. So what I will do, instead of x, I will again put sine theta. So instead of x, again put back sine theta. So e raised to sine theta plus c is the answer. E raised to sine theta plus c is the answer. Is that clear, my dear students? Okay, this is how magical the substitution method is. Okay, this is how it works. This is how it works. Cool? Till this point? All right. Now that you have understood how this basic substitution works and how this integration works, let's go to the second part of this lecture, which is basically called as definite integration. Now see guys, whatever integration you learned till now was called as indefinite integration. What is the meaning of indefinite? There is always an term which you do not know, and that is basically the constant of integration. So indefinite integration. It means that if the derivative of some function with respect to x gives me f of x, then it also means that if I integrate that function, with respect to x, I will get back that original function. I'll get back antiderivative, which is nothing but your g of x, and obviously it comes with an unknown, which is constant of integration, because probably the original also could have had a constant which we never knew about. So this is your indefinite integration. This is the indefinite part. So this is a big question mark which we do not know, which we call as the constant of integration. That is why indefinite. Indefinite means I don't know. It's a constant. I don't know the value unless you give me some other conditions to solve the question. So the next part is a definite integration where you don't even need that constant, because it goes off by a particular process. What is that process? Observe this. Say for example, definite integration, definite integration. Say for example, my dear warriors, I happen to integrate just like before, with respect to x, some function, let's say f of x, and I get the answer as, g of x and some constant of integration, This was indefinite because some constant is there. In in case of purely definite integration, what happens is you replace this integration symbol, or rather add to this symbol two new values, which is called as the lower limit and upper limit, which basically tell you, you have to substitute those values here and then subtract to get the final answer. I'll explain what do I mean by this. Look at this very clearly. This was indefinite part. So now, in case of definite, what happens is you put integration with respect to dx of this particular function f of x. But this time you are going to put some numbers over here, some limits over here. So one is the lower limit, one is the upper limit. This is your lower limit. This is called as your lower limit, and this is called as your upper limit. Upper limit. So what it means or what it tells you is, do one thing, just substitute instead of x the upper limit, just substitute instead of x the lower limit, and then subtract the two. So basically imagine g of x plus c and then g of x plus c. So this plus c is there, okay, and basically you are just taking these two things, subtracting by substituting this upper limit and lower limit over here. You're just substituting the upper limit and the lower limit over here in this particular term. And when you subtract, what happens? The constant of integration just vanishes. And what you are left with is g of that upper limit minus g of that particular lower limit. G of upper limit minus g of lower limit. So this is what definite integration is. You just have to put these values inside the final integration and subtract those two functions. That's all. There is no constant of integration. That is the interesting part. So there is no constant of integration left because it just got cancelled. Plus c and minus c just got cancelled over here. That's all. Lot of people, Pavitra, that is wrong. This is not the same. Please understand. Never ever do this. This is not the same of as g of u minus l. This is not the same as that. This is completely wrong. Do not do this. G of u minus g of l is not the same as g of u minus l. Completely different things. Be little careful over there. So let's have a look at some questions so that you guys get a hang of it. Right. Let's do this. Imagine I have to do integration of sine x dx from the limits, or let's do integration of cos x first. Integration of cos x dx from the limits pi by 6 to pi by 3. These are the limits of the integration. These are upper limits and lower limits. Let's do this. What does the definite rule say? Do the normal integration as it is, just that you have to substitute upper limit and lower limit towards the end. Okay, I'll do that. Normally, what would be the integration of cos of x? Cos's derivative is negative sign, so cos's integration is plus sign. So hence the answer would be just basically sine of x. You will not put plus c now. I know at the back of my mind, I have not yet substituted the limits. So the way I represent that is, okay, this is a temporary step. I have not yet solved it. I still have to put pi by 3 and pi by 6 in the answer, in the function over here. I have not yet solved it completely. This is an intermediate step which is put by brackets. It is shown as brackets. Now what you do in the next step is substitute pi by 3 over here instead of x, and then substitute pi by 6 over here instead of x, and now subtract it. Sine of pi by 3, sine 60 is basically root 3 by 2. Sine 30 is basically half. Hence, it is root 3 minus 1 by 2. There is no constant, it's a value. So that is why you will see the answer to the definite integration problems is not in terms of x, it is in terms of some numbers or some values that you will get. Okay, you will always see it is in terms of some values and numbers. Correct. Excellent. Let's have a look at more questions, guys, coming up on your screen. Let's look at more questions coming up on your screen. Imagine integration of x cube dx from the limits -1 to +1. Okay, this is the question. Let's see if you guys can figure this out. What do we do first? Just do normal integration. Just do normal integration first. X raised to 3's integration is x raised to 3 plus 1 upon 3 plus 1, which is by 4. Do not put plus c because there are limits. It's a definite integration, so no constant. I have not yet solved completely, so I represent it by putting square brackets. At the back of my mind, I know I have to put -1 and +1 over here. Okay, let's start. Always upper one first. Upper is given higher order priority. So 1, you put it instead of x. So 1 raised to 4 divided by 4 minus, you put -1 over here. So -1 raised to 4 divided by 4. So which is nothing but 1 by 4 minus, this is again 1 by 4. Hence the answer to this is a big fat 0. Just check this out. Just check this out if the answer to this is a big fat 0. Is that clear, my dear students? Is that clear, my dear students? Very good. Excellent. Excellent. Proud of all of you. Proud of all of you. Very good. Cool. So this is what definite integration is. You're just substituting it in the end. You do the normal integration first, okay, and then you substitute it in the end. All right. One more problem, my dear students, of definite integration. Let's see if you guys can do this. Integration of 1 by x dx, 1 to 5. Let's see if you guys can figure this out. 1 to 5. Come on, my dear students. So what is the answer to this? Integration of 1 by x dx, 1 to 5. Basically, do the normal integration first. 1 by x's integration is nothing but log of x. I will put a temporary step by putting the square brackets, lower limit, upper limit, no constant of integration. What I will do, first put 5 instead of x, so log 5. Then put 1, so log 1. And then subtract the 2. But wait a minute, log of 1 is 0. Log of 1 is 0. Any numbers, any base doesn't matter. But if you are finding log of 1, the answer is 0. Hence, the answer to this question is just log 5. Always definite integrations answers are values, numbers. They are not in terms of x. You can see all the values are there. Whereas earlier, we used to have x, theta, all these things. So now no more variables. It's pure numbers or values. But then you might be wondering, sir, what is the use of this definite integration? Yep. The use of definite integration is in finding areas. And you'll be like, so what is the use of finding areas in physics? Well, you find the area under graphs many times, like velocity time graphs, area is displacement. Force times area is going to give you the impulse. Area under force and displacement is going to give you work. Area under, basically, say for example, angular torque versus time is going to give you the change of the angular momentum. So you will see many times area will come in graphs in physics, and you will have to see that, okay, this versus this graph, the area represents this. So you will study that in physics in many places. This graph versus this graph, area gives you this quantity. Okay, so that is why you need to find areas. So what happens is, if you are given a graph, something let's say like this, something let's say like this. Let's just say that we have been given y is some function of x. Y some function of x, so it is probably like this. Who knows? Okay, something like this. Y some function of x. It could be any function, guys. It doesn't really matter. Okay, it could be any function. Okay, some function is given to me. Then when I integrate, when I basically integrate this, excuse me, when I integrate this function with respect to x, but with limits, let's say lower limit and upper limit, the final answer that I get, the final answer that I get is represented in the graph as follows. This is the function. You substitute L, you substitute U, or L and U on the x-axis will be somewhere. Maybe, L is over here, maybe U is over here. What you do is from L, you go up, from U, you go up or down, depending on where the graph is, and then shade this part, including this part, including this part. Including this part. Whatever area is there over here, whatever area is there over here, from L to U, from L to U is the value that you get over here. So this is basically area under, this is area under the graph from x is equal to L to x is equal to U. This is what definite integration actually represents. This is what definite integration actually represents, the area under the graph or the area under the curve. But yes, one simple thing which you should also remember is that when you calculate areas, they also have a sign convention. Meaning, say for example, this is our x-axis, something like this. Okay. Say our function went like this and came over here. Okay. And let's say it so happens that if you shade this area, the answer is 5. If you shade this area, let's say the answer is 2. And let's say these values over here are 1. This is, let's say, 6. Let's say this is 8. If I ask you, what is the integration of that function from 1 to 8, from 1 to 8, understand the answer is not 5 plus 2. In fact, 2 is below the x-axis, 5 is above the y-axis. So the answer to this question is this area from 1 to 6, which is plus 5. The area from 6 to 8 is not plus 2, it is minus 2. So hence the answer to this is just 3. So there is sign convention involved also. There is sign convention involved also. Similarly, my dear students, integration of f of x from 1 to 6, from 1 to 6. Just look at it, from 1 to 6, basically area under this part. The answer to that is just the pure number 5. Is just the pure number 5. Is that clear? Yep, very good. Similarly, if I ask you, what is the area under that graph from 6 to 8, from 6 to 8, then the answer will be negative 2. Then the answer will be negative 2 because from here to here, I'm going below. I'm going below. Correct. So keep this in mind that whenever your graph goes up and down, so whatever areas are counted below, they are negative, and whatever areas are above, they are counted as positive. They are counted as positive. Okay, so that is how the sign convention goes with regards to the areas under the graph. So let's see if you can do some questions based on area under the graph. Okay, very straightforward questions, guys. Let's see if you guys can figure this out. Imagine y is equal to x square. We know x square means it's a parabola. X square means it's a parabola. This is x, this is y. I know how the graph is going to look like. It is going to look like this. This is y is equal to x square. Question is find the area from x equals to 0 to x equals to let's say 3. Okay, that is the question. From x equals to 0 to x equals to 3, that is what we have to find. All right, let's do this. X equals to 3 and x equals to 0, maybe here and here. This is 0, this is 3. Okay, I just draw these lines. What I need to find is basically this particular area. So the area under the graph is the integration of the function. What is that function? X square with respect to x with the proper limits. What are the limits? Lower limit is 0, upper limit is 3. Okay, this is what it means. This is actually the formula version of the actual question. Now, x square's integration is x cube divided by 3, x raised to n plus 1 by n plus 1. Limits are there. That's why no constant of integration will be there. Last thing, what you will do is you will have to put the square brackets, put the limits temporarily. As of now, I have not yet substituted it. So let's substitute and see what do we get. 3 cube, I'll get 3 cube by 3 minus, put 0 over here, 0 cube by 3. 3 cube by 3 is basically 3 square minus 0, right? So this answer will be basically 9 units. So hence the answer to this question is 9. Hence the answer to this question is basically 9. Very nice. Moving on to the next question. Find the area under sine theta graph. Find the area under sine theta graph from 0 to 2 pi. From 0 to 2 pi. 2 pi radians is basically, one complete cycle. So let's try to do this problem even without thinking about the graph. Whenever we want to find the area under anything, I have to integrate that function. In this case, it is basically sine theta. And the limits are already given, 0 to 2 pi. Put 0 over here, 2 pi over here. Okay. Sine theta's integration. Sine theta's derivative is cos. So integration is minus cos. So this is minus cos theta. I have to put the limits. One is 0, other one is 2 pi. So put 2 pi over here. So minus cos 2 pi. Then put 0 over here. So minus cos 0. I have to subtract that 2. What is cos of 360? Cos of 360 is same as cos of 0, which is basically 1. So this is basically minus 1 over here. Minus. What is cos of 0? It is 1. So this is minus 1. Minus minus becomes plus. Plus 1 minus 1. Answer is 0. Does it make sense why the answer is 0? Yep. In fact, now that you think about it properly, if this is theta, this is basically sine theta, this is 0. The actual graph of sine theta would look something like this, and it keeps going up and down. This is 0. This is basically your 2 pi. This is 0. This is basically your 2 pi. If you notice, the amount of positiveness that is there, exact same amount of negativeness is there. So hence the total area from here to here, they will cancel out and you will get the answer as 0. Hence you will get the answer as big fat 0. But let's say if I had found, the area under sine theta from 0 to just pi. Pi is only till here, which is only that green part. This answer would not be 0, and we can see that also. Observe this carefully. If you want to find the area, I have to integrate sine theta with respect to d theta from 0 to pi. Sine theta's integration is minus cos theta. Limits have to be substituted, 0 and pi. So first put pi over here, so minus cos pi. Then put 0 over here, so minus cos 0, and then subtract the 2. Cos pi is minus 1. Cos pi, cos 180 is minus 1. Cos 0 is just 1. So check this out. This will become 1, and 1 plus 1, that's just going to be 2. Just check this out. So hence the answer to this question is just a big fat 2. Everyone with me? Clear till this point? How to solve these questions? Yep. Very good. Yes, Krishna, the answer is 2. So this is a job of basically, integration, to find the areas, and areas are, related in physics in many ways. So this is all that is there in integration, definite, indefinite substitution. Rest other things are just physics questions, which you will be seeing later on. Like you will see that integration will come in, just one of the first few chapters of physics, which is kinematics. Like integration of velocity with respect to time is going to give you displacement, right, with the proper limits t1 to t2. You will see integration of acceleration with respect to time with proper limits. You will see you will get change in velocity. You will see that center of mass formula XCOM will be integration XDM upon the total mass. You will see that probably integration of force with respect to time will give me impulse from T1 to T2. You will see integration of force with respect to displacement will give me the work done from x1 to x2. So you will see the application of integration in many different ways across physics. Many places you will see application of integration, okay, later on. So if you know how to integrate, that's it, the job becomes very straightforward. So bro, how was the lecture? I hope you all enjoyed and learnt a lot. Extra information ಬೇಕಿದ್ರೆ everything is there in the description box, including the PDFs and every other detail. And yes, do not forget to comment on how you enjoyed this class. And yes, smash that like button in case you have forgotten. See you soon.